Well, ladies and gentlemen, we are live. And yeah, what the hell happened with the schedule and the heads up that I was going live? It didn't happen today. Sorry. I thought last night, I thought before going to sleep, I had a schedule. So this was my time to come in. I was like, holy shit, I'm a little bit late. Let me go schedule it like to 15 minutes later. And I said, fuck's sake. Anyway, we are live now. Heads up. Shout out to 4 people watching. Thank you. That's Mr. P. Sean Hawkins, Channel Q, and myself. This is good. I like it. And then the rest of the people is in church, right? Shout out to Sunday. Some people is in church and some people is here checking out to see what's gonna go down today. I like it. I slept for a little bit, you know. You thought I was going live at 8 in the morning or 10 in the morning my time. I'm here, Davin. Do you want to do a presentation? D-Back is here too. So Davin, if you want to do a little presentation, I'll shoot you a link and then we'll open it up for everybody else. Yep. Somebody sent me a message on. Okay, yes. Somebody sent me a message on Skype asking me, "Do you stream today?" All right, so yeah, I'm a little still cuckoo waking up. That was fast. I had time to walk the dogs, pick up a little bit of trash around here. The wind, I think it was windy last night. I had a couple energy drink cans in here. It was all fucking blowing all over the place. Lamel Johnson say last night was a nice discussion. Yeah, thank you. I enjoyed it. It was good. Davin Good is not ready for a presentation. Okay. Morning, everybody. Oh, you're ready for the debate. I hear you. All right. Last check is going to be on. Oh, I'm sorry. I'm not even sharing the screen. I'll share in a second. Let me check on Discord really quick and see if anybody wanted to do something special presentation. If not, then I'll share the link in here in the YouTube chat. If anybody want to jump in, please jump in. I'm still waiting for the day that nobody want to click the link and I say like, oh yeah, I can just shut down the show for the day. I can maybe have like a half an hour show running, me babbling for whatever, and then I'll stop it. And there's always somebody that want to click and talk about something. It's okay. I'm happy about it. Yeah, nobody here in Discord. So that means, hey, good morning, Brenda. Good morning, Ali B. What's up? Tommy Grumbold. Hello from Norway. And I hope I didn't miss anybody. D-Back 7751. Now it's gonna maybe get a little crowded, so I think a lot of people is gonna start flowing over here. So please share the show. You share the show, copy and paste it. You don't have to click the share button and create a post. If you do that, that'd be awesome. Okay, Channel Q, thank you. Just listen around. Twisted Hippie, hello. Share the show, copy the link and paste it in Twitter, Facebook, in another YouTube, go in whatever little Skype group chat you're on. And just in the Discord, share it. Good morning, Brenda.
Good morning.
How are you? How are you doing?
Oh, I've been up for about an hour and a half. Still waking up, not finished with my coffee.
Yeah. Still in the process, in the ritual of waking up.
Hello.
Hey, Tommy, what's up?
Yeah, it's cool.
Good to see you, man.
Yeah, you too.
I have every espresso in the morning. It's a little Italian espresso maker. It's actually stovetop. They call it mocha. It's this little. It looks sort of like an hourglass. It has a sort of a narrow waist. They cost about $40 or $50, but it makes halfway decent.
Holy shit.
It's not technically what?
Expensive.
No, are you kidding? A drip coffee maker costs about that
Oh,
much.
coffee maker. I thought it was the coffee cup. I was
Oh,
like,
no, it's
damn.
the coffee cup. This
Okay,
is the
coffee maker
coffee
is cool.
maker.
Yeah, that's cool.
It's a stovetop thing, and it's a little aluminum, and it has a little handle on it. Basically, the bottom gets filled with water. You put it on the stovetop, and it goes. It doesn't percolate. It doesn't recycle. It just goes through once. The steam forces it through, and technically, that's not actually espresso, but that's what I call it. It's strong. It's stronger than drip, which is what I like.
Cool. Yeah. All right. I got morning, Davin. What's up, man? Tommy is here, and Tommy's got the debating spirit. He wants to get somebody a one-on-one. There was a little bit of an interaction early. Was it yesterday or the day before with Red Pill Philosophy in the chat? And it was a little bit of back and forward.
Tommy, you're from Norway?
Yeah.
Yeah, I live here in Minnesota. There's a lot of Norwegians and Swedes here. In fact, I'm not very far away. I'm only a few blocks away from a Swedish museum here in Minnesota. Because historically, Swedes, Norwegians, and Finns up in northern Minnesota are fairly common.
It's the big community.
Yeah, it used to be.
So
Red Pill here.
Talk to me about Red Pill, because I mean, he made a little video answering you, and then you made a video answering him. So I like that. I like the back and forth.
He made a video about me. I haven't seen that.
I think I seen a short video. I'm gonna
cool.
High IQ skeptics in the house.
Hey.
Yeah.
Is this Davin?
The thing is, it was 2 days ago in our hangout number 78 or 79. And he challenged me to a debate. And I got one single comment wrong about where he wanted to have it. So he went total bananas on my comments on my video and calling me retard and everything, and just, full retard. Because it was all my fault. I wasn't challenging him. He was challenging me. And he ran away. So, he's bitch made.
Yeah, I'm looking for the video because he put a 1 minute
Hey, what's
video.
up, everyone? I'm going to be doing a sort of a live interview, sort of like bar or something with a little science channel.
Yeah, this is it.
No, that's not it.
No, that's not it. But I heard him. He talk about it. He say something maybe in his secondary channel. I gotta look for it. Because
if you look on your video from 2 days ago, that number 79, you can have all the chat there is all black on white or white on black, and he challenging me and backing away. So, he's a coward.
It's all right. Maybe someday he'll step up. But you know what? The beautiful thing is, Dabbing Good is here. And you can maybe have a little go with Dabbing Good. Get a little back and forth. And I will enjoy that very much. You guys want to go for it.
Cool. Which one is Dabbing?
Oh, he's not me.
Oh, I'm
Okay.
I'm in here. I can hear you. Go ahead. Start off. You want to ask something?
Yeah, I just know why do you think the Earth is flat?
Mainly because of observations, and I have seen no proof of curvature. I lived on the water for 40 years, actually about where Jose lives now. And all through my life, I've been out in the water, looking at the water and the ocean and all that stuff. And then once I found out or became known that about the curvature calculator, I was like, oh, that is totally bullshit. And that led me to my journey. So that was the one main thing that helped me do it was living on the water and knowing that I could see things from very far away with cameras and stuff. And then when I found out the curve calculator, I was like, that's complete bullshit.
Just looking at the water or doing some actual observations?
Well, I mean, that didn't even do it, but just living on the water and being able to see. I mean, like, I can tell you, it's like probably 12, 13 years ago, I had a camera that we got that was like, I forgot, it was 10 optical zoom and like 80 or 800 digital zoom. It was like off the chain. And I used to get out in the boat and freaking zoom into people on bikinis fucking 3-4 miles away and be like, oh, yeah. And then next thing you know, when I got the curve calculator, I was like, well, that's not supposed to be possible. You
don't need all that zoom. I got 400 millimeters. That's more than enough to show the zoom, to show the curvature.
Oh, so if you have shown the curvature then. You think
if I can screen share, I'll show you.
All right, let's see it. Let's see them. But see, I would say that you need a time lapse because you're going to see that the curvature changes throughout the day. And unless you want to claim that the Earth is expanding and contracting as the curvature is, then, I mean, this is absolutely known that the curvature, their so-called curvature will change throughout the day.
Jose, can I screen share?
Yes.
Cool. Nice.
Top 3 dots.
Yeah, I know.
Yep. Good.
Just want to be sure that it's okay with you. So, do you see this?
Cool beans, yeah.
I got 2 tripods with a water level on it. That's 4 or 5 feet between them. You see that?
Yep, I see them, yep.
Yeah. And I shoot over it. That's my eye level.
All right.
Yeah. Well, where's the horizon?
That wouldn't be your eye level.
Yeah, it's just across the water.
Because if you're looking straight up, your eye level is not going to be the horizon. You think, I don't think that's eye level. How's that eye level? Is that where you're looking at? I guess you took the camera and got down and try to put that in the middle of your thing. But think about it. If you were
shot across that water level.
You people think that if you go up and up and up, the friggin' horizon should never change. That is ridiculous because you're not going to be able to see forever. So therefore, the more you go up, naturally, even on a flat surface, that the horizon should drop a little bit, but it don't drop.
How's the mic? How's the mic, guys?
Good.
Yeah, we can hear you.
The horizon doesn't drop anywhere near the calculations that the heliocentric math should.
Calm down a bit. Just calm down, please.
What do you mean? I'm not even fucking. I'm not yelling. Believe me, you would know if I'm yelling. You wouldn't be able to get a word in.
Just, I'm shooting across that water level. That's about 70 feet above the water. So that's my eye level. I'm shooting across that water level. Water is level. That's my eye level.
I still don't understand your point, though.
Yeah, where's the horizon?
Even if you say that, so you're saying that proves the curvature because it's not the horizon isn't eye level. Where's the other part of this? Back up and show me both of these tubes of water too. You're only showing one, so that's really not. You're only showing one side of the water. You're not showing that both of them right. See, you got one going to the other camera.
Here and here.
All right, it was both of them in the other picture. I'm not sure if they were or not. Okay, there you go. All right.
Yeah.
Still, that's not.
Doesn't water always find its level? Water always finds its level, right?
Yes, of course.
So
but just because the horizon is not rising all the way up to, like I said, take a time lapse of this, and you will see that the horizon changes during the day. It changes completely during the day. We've seen that in the Skunk Bay footage, where the horizon blocks out the whole friggin' island, and then 4 hours later, you can see the whole island.
Can I ask you one question? What's your law of perspective?
What do you mean law of perspective? I'm not sure
what is your law of perspective? How do you understand perspective? Vanishing point and all that.
Perspective, it has so many variables on it. It's not just one thing. You can't just say one thing. Just like y'all claim to think that it's curvature blocking everything out when there are so many variables that have to do with perspective. That is, it's almost uncalculable.
But do you think that it allows something above eye level to go below eye level?
I'm not sure. That looks like something's going on there because that seems very dramatic. That is a very dramatic drop right there. And I've seen other people do this, like friggin' Dave Thomas of New Mexico's for Science and Reason, and he climbs all the way up on top of probably about 7,000-foot mountain, and he looks at another mountain that's friggin' 100 miles away that is 10,000 feet. And he says, well, since that dropped below the horizon, that or dropped below the water level, that means that the Earth is curved. No, because one, apparent size is going to happen, and number two is that the farther you go up, it limits your distance. Therefore, it should drop, but it don't drop nowhere near it way it should with a friggin'.
Yeah, but could you please stick to this, please? Don't go anywhere else.
I'm just telling you, I've seen other ones. I'm just saying that is pretty. Yeah. That is a pretty minute. How far away is that island right there?
About 20 kilometers or something. Yeah.
All right.
But
so
you see behind here. This is still my eye level. Now it's zoomed in.
That is 20 kilometers away. There's no. That's how high is your observation height?
22 meters or 70 feet. And that lighthouse.
Okay, you're 70 feet.
That lighthouse is 47 meters high. So I'm just about halfway up.
The only thing these ball earthers are going to listen to is bullets. We need a call for violence against all the globe Earth.
Why
This
is
is
that? I
a-
don't, you can't call for violence, but yeah, they're never gonna take in consideration. I believe
It
that.
seems like every photo they're just gonna explain away with refraction and lumen and Rayleigh criterion and shit like that.
No, they say it's curvature. It don't matter. No, they don't use refraction. They don't use Rayleigh criterion. They say it's all curvature. That is the problem. They think every picture is friggin' curvature and won't consider
Yeah.
anything else.
We need to
I
rise
have an
up.
idea. I have an idea on why things disappear bottom down first.
Jose,
Maybe it's because the floor is more accessible than the sky. So when our eyes are compressing, it needs to compress whatever the sky is, and the sky is further than the ground. That's why maybe.
I apologize. Nobody's being heard, only me in the YouTube. I'm gonna stop this hangout. I got Davin, I got Brenda, I got Tommy. Contact. I'm gonna send you guys a link, and if Matrix Media wanna contact me, I think I got you on let me see, Discord. So I'll send you a link. P-Mars, you're not welcome here. Thank you. I'm gonna close this out. All right. Okay. Let me open this again. So let me open the Hangout, another page, and I will send a few people Hangout link. So if I open this video call, I can stop the screen share, and you will not see what the link is unless somebody share it with you. So we're gonna have a nice, mellow, cool show with no disruption. If somebody want in, just shoot me a message on Skype or Discord or email, and I am more than happy to have you on the panel. As for right now, this is beautiful, it's perfect. Nobody say nothing out of the ordinary. Nobody say nothing. It's all good. Okay, I'm sharing my audio, the Mexican audio. So I'm gonna stop this. I'm gonna send a few people a link. Let me open. Hang in there. I'm opening the Skype first. And Brenda, you got the link right here. Boom. Okay. Okay, let me minus the Skype. Hang in there, guys. I am going to. Are you here, Brenda?
yes, I am here.
Oh, okay. What's that? I'm kind of multitasking, sending some people links, so you can speak if you want to.
Sure. Angle of attack and compression, these are not things. These are made up things. Nathan Oakley just invented this idea that angle of attack somehow affects perspective and can hide things. Angle of attack is not a thing known in optics at all, right?
Yep.
I'm just making time until people get here and we start again. Okay, so
angle of attack a term like for really is something else for like a military or boats or I don't know.
I don't actually know.
Aviation.
I honestly think he just made it up. So the way things really work by people who are actually trying to discover the truth is that they don't just look on YouTube for videos that confirm their beliefs. What they do is they try to prove themselves wrong. You have an idea, you have a hypothesis. I think the earth is flat. So then you go out and you try to prove yourself wrong. Is there anything that would go against my idea, my hypothesis that the earth is flat? Well, then you go and you look for evidence that disconfirms your beliefs. That's how real science works. It isn't about going out and trying to confirm your belief. It's trying to disconfirm it. And where are the flurfers? Are we waiting for them to come back?
I sent Matrix Media a link on Discord, and I'm looking for Davin Good. I got him on my emails, and think I got him right now. Yep, I got him right here.
Okay.
Yeah, because we'll have the same people we had before without the interruption.
You can't allow the other person who shall not be named.
Yeah, I appreciate that.
Cannot be it. Can't play nice.
Yeah, if
so
he can't play along, if he
know
cannot
who you
play
mean.
with others, then you're non-play.
Yeah.
Period. I mean, that's it. All right. Matrix have the link, and Davin Good got the link.
Yeah,
I'll keep monitoring the the Skype and the Discord and see if.
Yeah, Davin Good has a hard time not understanding when he's really pretty heavily triggered and excited and shouty, and he doesn't realize it.
Yes, because it's not. I'm not like that. I'm like that naturally. It's not that I'm being all mad, but I naturally talk fast in conversations. I naturally do that.
Well,
I mean,
Yeah, that's cool.
You could just,
Me too.
Okay. Okay. Go ahead.
the comment on here. I just want to say that the comment about him making up a word, every word is made up. Every definition is made up. We are trying to explain stuff that hasn't been explained to us before. So therefore, we have to make up terms to try and explain what we're talking about. For instance, when somebody now says angle of attack, you know exactly what they mean, don't you?
No, I have actually no idea what they mean.
Brandon, yes, you do, because you were just talking about it. You know exactly what we're talking about when we say angle of attack. Just like everybody in the chat, was
you and Tommy.
That's actually called the angle of incidence instead of the angle of attack. Okay, we can use the angle of incidence.
Oh, I know what that is, but that's not the same thing. And
the angle of attack is the same as perspective. You have all the meanings that needed to be used, so it's just lost its value.
All right, before I mute myself, we got Brenda, Davin Good, Schrodinger's cat, Tommy, and Zinder. Thank you guys for being here.
Zinder is a flat earther. I don't know if we can have that flat earther in here. Get rid of this Zinder person, right?
I would like to ask Jose what happened to George. Because I was expecting a presentation from him, but I heard that something happened and he wouldn't join anymore. So does anyone know?
I'll touch really quick this for the last time. George tried to the way I felt it, he tried to control my show, control me, tell me what I need to do when I know what I needed to do. So I felt disrespected by him. He doubled down on saying, no, this is what you have to do. These people you can have, these people you cannot have. He might have been right, but the approach he took was the wrong one, and I didn't appreciate that, so he's out of the show.
All right,
so George is not part of the show anymore. Thank you.
Yeah, so he might have to do his rebuttal of my presentation somewhere else, I guess. All right, but thanks for the information. Go on, guys. Sorry.
Yeah, angle of attack, perspective. You misused all of that too many times, so it's lost its value. It's not worth anymore. You just don't. You have no description for it.
Angle of attack is an aviation term. It has to do with the attitude of the aircraft in the air. I don't know how they appropriated that to be flat Earth something.
Yeah.
Let's call it angle of view then. Because angle of attack, as Brenda, I think said, or as someone said, that he invented that. Like, it didn't invent the name, obviously, because it existed before, but he put the name on the angle of view thing in order to make it sound a little bit more provocative, which is probably his specialty on stuff. So yeah, let's just call it angle of view.
If the word has no definition, you can't use it. As simple as that. Perspective has its own law, and it's misused all the time. It has no value anymore. You just have to find something new.
Well, Tommy, you and Davin were just beginning to have an interaction back and forth, and I was kind of hoping that would continue. So you two can please continue.
Do you see my image again? My photo.
I do.
Yeah, cool.
Davin seems to be AFK.
No, I was actually.
Okay.
on in chat, but what are you trying to say your picture proves? I'm not sure. Okay, so we got that the horizon is dropping or whatever from eye levels. That I guess that's what you're trying to state. But that has many variables. We don't know if your camera was actually eye level. We don't know all that stuff. I can do stuff
I
just
just
like
showed you.
Oh, you put a water level. That doesn't mean the camera's level.
Yeah,
How does that mean your camera's level?
I just showed you in the picture here.
No, you're showing me a picture of the water level. You're not showing me a picture that your camera is actually level with the water level.
Does that really matter?
It matters a lot.
Yeah, let me show you. You see this one? That's my camera. That's level with the water level.
All right, now
Do you
that
agree
would
on
be
that?
more difference. Then you would see the water going through the thing. That would probably be a little more better showing that it is level with your thing.
Yeah, so that's level.
Oh wow, it matches pretty good with the horizon right there. No?
Yeah, sure. How about this one?
All right.
Is that camera level?
No, of course not.
Yeah.
Yeah, it's level.
Is that eye level?
Oh wow, look at that.
That's eye level at the bottom of my screen.
Mhm.
How about that? Is that eye level?
All right, continue.
Yeah, still water. Still eye level at the top of my screen.
All right.
Yeah, so it doesn't matter.
I'm not sure what all this means exactly. What does it matter?
I think let me see if I
mean?
understand, Tommy. So what you say, it doesn't matter where you point the camera. The camera could be tilted up, tilted down, to the left or to the right. You can determine where the eye level is if you got some kind of a guide like these little pipes, few pipes,
Exactly.
the same amount of water, and it give you a actual level.
Exactly. Thank you.
Yeah, it's funny you want to use a water level to prove freaking curvature when we know that water is level, but yet you want to claim that it's curves. That's what's ironic about it.
And then tell me this. You see here, those wind turbines. Those are standing on a 150 meter or 500-foot hill, and those windmills are 500 feet tall. So the top of those windmills are 1,000 feet high. How come they are below my eye level?
Apparent size. The farther something gets from you, the smaller it will be. And this smallerness is from every angle. It shrinks from the top, the bottom, the left, the right. It doesn't just shrink from the left and right and leave the top where it's supposed to be.
So how can you hide that on the flat Earth?
What do you mean? How can you hide that on the flat Earth?
Yeah, this is a flat Earth. This is
I just told you, apparent size. The farther you
You're
get,
not supposed
Yeah.
to be forever on the flat Earth, anyways.
yeah, the farther you get from something, the smaller it's going to be. This
Yeah.
includes height.
Yeah, but how does it go from above eye level to below eye level?
2 words: apparent size. I don't know how many
That
times
doesn't
I'm gonna
matter.
say that. Yes, it does matter. That is what you're looking at. You're looking
That's
at
perspective,
apparent
right?
size.
Yeah. Apparent size is perspective, right?
It's part of
Perspective-
perspective. It's part of perspective. Has a bunch of different things to do with it. I mean, your
No.
perspective has so many variables. Yes, because perspective is what you see. What you personally are seeing is your perspective. Therefore, it has so many variables that friggin'
He's not talking about the fact that they're getting smaller. He's talking about the fact they can go below the eye level.
yes, that's because of perspective.
No, it isn't.
No,
Angular
perspective
size.
is just
It's
perspective
friggin'
is just
apparent size.
perspective.
It's apparent
Perspective-
size.
Perspective is just apparent size.
I
Things
should-
get smaller. That's it.
I should be looking up to
that
those
includes height.
wind
That
turbines.
means the height is going to drop from the apparent friggin' where
Yeah.
it should be to below your eye horizon because it's getting an apparent
Into the
size.
vanishing point. Into the vanishing point, not below.
Dabin, if I have a line of telephone poles, right? They go into the horizon, right? They appear to get lower in the horizon, right, Dabin?
What's that? Repeat that again.
A line of telephone poles. It
Mhm.
looks like but if you were to go to the last telephone pole that's far away, looks like it's right on the horizon. It isn't actually on the horizon, is it?
No, but again,
Right.
you just proved my point. The
Right.
same thing with those telephone lines is the same thing that's happening with those windmills.
That's not what's happening with the windmills.
How
The
is it not
windmills,
happening? You just stated it is. Come
they're
on,
going
Brandon.
below eye level.
Perspective doesn't allow that.
Just like the telephones would go below eye level.
No, they don't. They never
Okay.
would.
Parallel lines.
Okay,
never
can we
cross.
agree on that we don't fully understand how perspective and everything goes together yet?
Oh, I would definitely agree on that.
But it doesn't necessarily prove a globe Earth.
Yeah, don't prove globe and don't prove it's flat. We're still trying to figure out how our freaking eyes work.
This is not true. A child understands.
We cannot
You
assume
don't.
that simply because
You
it's
don't.
flat. We could.
Yes,
we're
you
theoretically
can.
able to see
You know what?
forever. We
There's-
don't know if that's
Yes,
how it
you
works.
can.
There's
Yes,
two things
Yes, it is how it works.
the globes could prove for me to become a globe earther. One is that
It
water
just seems like a
will
logical
conform
fallacy.
outside of spinning objects. Number two is prove that the motion of Earth. Because if we're moving millions of miles an hour, you can't tell me we can't detect that shit. That is such a ridiculous comment. Those two
Point
things.
one, gravity.
prove-
Just deny it.
You can't prove gravity, so you're trying to use a theory to prove another theory, or an
Brenda,
assumption to prove
doesn't
another
that seem
assumption.
like a logical fallacy, Brenda? To assume that one will be able to see forever on the flat Earth?
No, that's not a logical fallacy.
Well, I mean, there is air in the way, right? I mean, we know light refracts. We don't understand light itself, but we know it refracts. So obviously, the air would at some point be in the way, and we couldn't see forever on the flat Earth.
Can I add something?
If we had an infinite powerful telescope, we will still not be able to see another continent from Europe, for example.
Give me 1 minute. I'll be right back.
I mean, look at my picture, right? Look at the hallway. This hallway is perfectly straight, and look how perspective tends to put it at an angle.
To the sconces at the far end of that, let's say that they're about 6 feet off. I don't really know.
What I'm trying to
assume.
Brenda, what I'm trying to say is, if you take away the walls, perspective works like that in everything.
Yes, I know.
In everything.
I know that.
All right.
I
And
figured
maybe
that
the
out.
reason it compresses from the bottom first when we're taking pictures of the ocean is because the ocean is closer than whatever's in the sky. So the eye compresses what's in the bottom first. Maybe that's the explanation, and you don't have to go into
That's
some
not compression.
mathematical wizardry
to-
in order to be able to understand it.
I would
It
like
has
to
to
comment about this
compress.
picture. Hey,
Like
Brenda,
this long way, like this hallway. And we know it's perfectly straight, everything, and look how it's compressing. Everything
Right.
perfect, nice and even.
look at those lights. Look at those lights. See how the lights are above the camera angle, but look where they end up. They end up where?
In the
At eye
center,
level.
in the middle.
Exactly. They end
That's
up,
the horizon. That's the
but
horizon.
yet they were above the eye level when they first started.
No,
But do they
they're
ever
not.
go
They're
below
above the
eye
camera.
level?
Yes, they're above the camera.
Will they
Yeah,
ever
they're-
go below eye level?
Eye level is a horizontal line drawn right at the center point, correct?
So tell me how those lights go from being above eye level to freaking at eye level.
Yeah, that's perspective. How do they go below eye level?
They don't. They can't.
Yeah.
Ever.
Sure. Okay.
Well,
That's what Tommy's photographs show, is that something that can't happen due to perspective. Due to perspective, those sconces, those lights, will never go below eye level. Eye level is the horizontal line at the center of this photograph, right? They would never go below. Never, ever, ever. That cannot happen.
So
But
Tommy,
he's showing something that cannot happen, and you can't explain it.
So you're saying it can go above eye level, but never below eye level. Is that what you're saying?
You can't cross it. That's it.
Hey, Tommy,
Yeah.
how high up is the line on that lighthouse? That first white band. How high up is that?
That's about 22 meters. That's halfway up. The lighthouse is about 47 meters high.
That's about 66 feet. Roughly.
Yeah, just about there. Yeah.
So, and you're at what, 50 feet above the water?
I'm about 70 feet. I'm
That's
just going
70
to
feet.
share again.
Wow, you're using 6 feet in meters. So you're saying that where you're sitting at is exactly midway between that lighthouse.
There.
Right. And the lighthouse should be taller.
What do you call that? The height of the light is about 47 meters.
Now I'm talking about where the bottom of the white band.
Yeah, that's just about there. That 22. Yeah, I mean, it's no measuring at the exact point, but
Right. So
just
you're
about halfway up.
so you were consider on a flat plane, that line where that is on the lighthouse would be way higher than your head, than where you are on the dock or on the
Yeah, the
deck,
top
right?
of the lighthouse is twice as high as me. Yeah.
I would
Right.
just like
So
to ask.
let me finish. So on a flat surface, if you're looking straight forward, you should only see half halfway up to that black line, right, Davin? Because parallel lines never cross.
Well, see, if you were listening to what I was going to say before that, I was going to say it seems like all this is assumption. Did you actually get out there and physically measure how far you were off the surface of the water? Did you go out there and actually measure where that paint stopped on the lighthouse?
I got that from Google Maps. I'm at 22 meters above water.
Oh, yeah. It showed the white paint. The white paint was 22 feet off the ground.
No, that's my eye level.
You guys see my screen share over here? This was shared. This was shared from the chat. What do you guys make out of this picture?
I'm just going to stop here.
Pretty crappy picture.
Looks interesting.
What do you guys think about this?
I didn't see it.
Oh, click on my icon.
You got to keep talking.
To make any
click on my icon in the bottom, and then I'm presenting to YouTube.
All right.
You gotta click on my icon.
I just stopped sharing, so yeah.
I might have a theory why things disappear button first and how this picture might come to be. It probably isn't right, but I'm just gonna present it.
That boat isn't a fake.
Sorry, go on.
Oh, I was gonna say that boat isn't fake. That's
cool
a real part of the image. Holy shit, that is crazy looking.
Yeah.
So you know how light converges and annihilates each other. The waves of light, right? Like the same in the ocean. So when light travels over a surface, the surface reflects light, and then it will annihilate certain waves and will convert certain waves. So it will make a.
I was in the middle of trying to explain some shit. Thank you, everybody. Fuck.
It makes.
Oh, Jose, you've ruined his day, Jose.
Okay, I think I scared him away. Fuck. Okay. I bullied Sean away. Sorry, Sean.
There's time. I mean, yeah.
Blame it on Jose. He's the one that put the picture up.
I brought the picture because you guys were talking about it. I just wanted your opinion.
So anyway, the reason why things disappear button first might not be because of perspective, but it might be because light annihilates each other when the waves are right. So yeah, that's the reason.
Wow, this is giving me a headache.
Okay. Do you have a counter argument, or are you just going to say how much of a headache you have?
Worthless assumptions. Just prove it somehow.
Well, that's just an idea. I mean, the Earth.
Yeah, an idea. Yeah.
The globe, the curve hasn't been proven too. So we are just talking about conceptions instead of actual evidence.
I can show you more coverage if you want that.
Well, I can explain it with my conversion and thing about light.
How about this one? Do you see this?
Who am I supposed to? Matrix. Okay, Matrix. Okay, Matrix. Yeah. There we go.
Yo, what's good? What's good?
All right. What are you trying to say? This is showing.
This is a straight board along the horizon.
Yeah.
Yeah.
I'm looking at the wrong. Oh, I'm looking at the wrong one. I'm looking at the hospital sign. Okay.
Yeah, that's curvature.
Curvature.
Yeah.
No. We've already go look at Ranty. Ranty's doing a good job on this, and he's going to be doing.
No,
more
he doesn't.
Ranty is showing that there is bulges in the water from friggin'
that could be distortion from the lens itself, the little curvature lens.
Or exactly.
Why do you think I have a straight board there?
But he's also showing that bulges will be there. And matter of fact, you can go look at the national or NOAA and stuff like that, and they will show you the swell is friggin' different in different areas where you will have a swell
because people is getting pissed off that I'm interrupting other ones, and this is what pissed the fuck out of me. And I'm gonna fucking start venting again. So if Sean Hawkins, Bob the Science Guy, whoever the fuck you think you are, if you don't want to be part of this show because you don't like how I run it, get the fuck out of here. Unsubscribe and get the fuck out. Don't watch anymore. If you want to participate, click the fucking link. Contact me and jump in the show and fucking deal with it. Get fucking thick skin. Don't be fucking whining in the chat and telling me what the fuck to do and how the fuck to do it. Get the fuck out of here. Do it in your fucking show and let me do my shit. Continue, guys.
And next up,
why do water have bulges? Isn't water supposed to find its own level?
I just told you there's bulges because the water is not. it finds and maintains level when unmanipulated. The problem we have is that the water in the oceans is manipulated by wind, by like if there's a mountain or whatever or a peak underneath the water, and when that water hits that peak, it's going to naturally push up on the level, the surface, and create a bulge there.
No.
No, you can do this yourself. Get a tub of water, put something underneath the water big, and then push the water. Make yourself a wave and watch the bulge that happens next to that friggin' mountain that you put up in the water. I mean, it's obvious that we know that. We know that wind, the same thing. When wind hits that mountain, it actually hits the mountain and goes up, pushing the rest of the air up, creating air currents that go up the mountain. Same thing with the water. It's pushing the water against the mountain, which naturally forces the water up, creating a bulge.
So you're saying that when a force is applied to water, it will change its shape?
The thing is, Dabin, this is the Oslo fjord. This is in a fjord. You have tide going in and tide going out. Between that, the water is still. So when there's no tide going in or out, that water should be still. There should be no bulge.
Look, go back to that. Go back to that satellite thing, and look. There's mountains right up underneath in the middle of that friggin' view right there. You don't see those bumps underneath the water.
There's no mountains here.
Therefore, it could create. What do you mean? There's no.
This is flat.
There's obviously bumps underneath that water that I can see through the satellite imagery right there. There's obviously mountains and peaks and troughs and all underneath the water.
Yeah, but the top of the water is flat.
But if it was.
Are you saying that water goes up and down depending on what's on the bottom?
Ranty is doing a great job of showing this. He has one spot where every time. Yes, he does. Yes, he does. You can go look at his things and you can't debunk it. He shows where at one spot he's always getting obscured by one spot. It's not because of curvature. It's because the way the Earth is underneath the water there that is pushing up, creating a swell right there at that one point. Because if he goes anywhere else, he ain't getting the blockage.
So water doesn't find its level then.
If I go anywhere, just a random
water
place, whatever.
It maintains its level when undisturbed.
Dabin, if I go anywhere, just a random place, wherever, and I find this curvature, what did I tell you? Anywhere, just random place.
Well, I'm not sure because this is there has to be something going on because this ain't
curvature.
You call every picture. Why does every picture not show like this? Why is every picture not showing curvature like this?
Because you don't do it the right way.
What?
You don't do it the right way.
What do you mean we don't? What? So everybody in the whole world is not doing it the right way, but you find one picture, just like Soundland's one picture that proves curvature.
Flat earthers don't do it the right way because they need to have their beliefs. That's it.
So, like, we would agree that in the middle of the bench, this farther away and left is a little bit to the left it is farther away, and in the middle it is closer. So light has way more time to interact with it. So.
Please stop it.
Look at this picture right here that you got right here. Matter of fact, it looks like the water is actually going from its high point on the right all the way to the left. And so what is that?
Because that board isn't perfectly level.
Oh, now the board ain't. But you just used one where the board was. See. Change
the board. The board is flat. Isn't the board flat?
That's showing Earth as a plane. That's showing Earth as a plane. That back picture, the last picture you just showed Earth would be a plane. Yes, and notice the water on the right is way higher than the water on the left.
Yeah. Because the board isn't perfectly level. I was alone there. I couldn't go.
It's perfectly level.
Hey, listen. Okay. Hey, listen. I was alone there. Shut up for a minute. I want to explain this. Shut up. I was alone there. I was going back and forth to my camera.
You took a picture without the board being level. You did that? You took the picture without the board being level? Why would you do that?
I was alone there. I went back and forth to adjust this. I had to look at my screen and go back and forth to adjust this. I didn't get it perfectly straight. What does it matter? The board is still straight. The horizon is not.
All right, so the board's straight, but yet it's showing the water higher on the right-hand side than the left-hand side.
So what? It's curved.
No, that's not showing it's curved. That's showing it's a friggin' plane. It's showing it's an angle.
There's a difference. Do you know the difference between flat and level?
Let's see. Flat is level, but level doesn't necessarily mean flat. Yes. Level doesn't necessarily mean flat or
right.
flip.
So
flat doesn't certainly mean level, but level does mean flat.
Right. So a board can be flat, but it can be not level.
Exactly. Yes.
Right. So the fact that it's a little bit higher, the fact that it's higher on one side is irrelevant.
What do you mean it's irrelevant?
Because it doesn't have anything to do with what was being looked at.
he is using a board to try and prove that there's curvature, but then when he one of his shots show that it isn't curvature, it actually shows that it's slanting from right to left.
Yeah, but that's because it's not perfectly level, but it is still flat.
Well, that's what you claim, but if it showed that it was curving, you would say, "Oh,
you can see that it's
level.
flat. You can see it's flat."
Come on, the dude's got the freaking clips on there. He leveled that board. You could tell he leveled that board before he freaking took the shot. What did he just take a shot before he even clipped the board up? What, he just clipped the board up there without leveling it? He walked away. I'll level that board. I'll level that board later. We'll just take a picture of it unlevel.
How many excuses do you need?
What's that?
How many excuses do you need?
Excuses? Oh boy, you have excuses. That all the Gold Globe model is nothing but excuses.
So Dabin, if you took it, even if you take his picture and you put it in Photoshop and you rotate it so that the board is perfectly horizontal to the frame of the picture, the other line, which shows the curvature in the ocean, will still be curved.
Again, I am stating that this is some kind of either it's create. There's mountains underneath there creating a bulge, like Randy's been pointing out, or there's some optical phenomenon, your lens or whatever. Because the very fact that there is millions and billions and trillions of pictures around that show no curvature like that says that is an optical phenomenon or something else going on than just being the way the Earth is. Because a million pictures contradict your picture.
It's easier to show flat than a sphere. That's why you do it the right way.
So, I mean, it's just like Stanley. Stanley proves he has curvature. Well, why don't the other millions of pictures, millions of videos show the same curvature that Stanley's showing?
Because they don't zoom in.
Because it's an optical phenomenon and not the curvature of Earth.
Do you believe GPS works? Do you use GPS in the car?
Yes, of course. Who doesn't?
Yeah. So GPS works, no matter if it's satellites or not. GPS works.
That doesn't mean it's coming from satellites. It doesn't mean that Earth's a ball.
It doesn't matter, right?
Even if it's coming from satellites, that doesn't make Earth the ball or whatever your claim of satellites is.
And it doesn't mean if it comes from satellites that it's orbiting the space.
Exactly. It could be
in a balloon or something.
It could be a drone or a balloon or anything else.
Doesn't matter.
Exactly.
Doesn't matter.
It
GPS
will work
works.
the exact same way.
Yeah. So when Jesse Kozlowski measured this bridge with GPS, he got that curve matching the bridge. With GPS.
Oh, sure, Dave. Sure. Again, a coordinate system is not conducive of reality.
Yeah, well, when the coordinates follow the geometry, when the coordinates follow the geometry of an object, then the coordinates do indicate geometry.
I have a video on my channel that completely debunks Stanley's shit right here. It looks and sees straight across the whole friggin' bridge and sees land on the other side, which Stanley's doesn't do. Matter of fact, everybody's picture, and I'm going across.
How do you explain that curve? How do you explain that curve?
It is an optical phenomenon, is what it is.
GPS is optical.
He has to be in that spot. He has to be in that exact spot with that exact focal length, with that exact.
No, he doesn't.
Yes,
he's done the same photograph from different angles from the other side of the bridge.
Well, then explain the video on my Explain the video on my channel.
Explain the GPS first, please.
Explain the video on my channel.
Explain the GPS first. How does GPS make that curve?
What do you mean GPS? It's math. Math is not reflective of reality.
Yes,
GPS works, right?
No. You can predict things, you can do it, but you can't prove things with math.
Yes, you can.
No, you cannot. I can show you math that says I'm a millionaire. Math says I'm a millionaire. I got $1 million in the bank, but guess what? When I go try and withdraw that fucking money, it ain't there.
I can prove something with math. Want to watch me prove something with math?
All right, go ahead. Let's
Brenda, can you show me -3 apples, please?
Yes. So if I have 2 apples and then I get 2 more apples, I can prove that I have 4 apples.
No, I need you to physically show me -3 apples, please.
Yeah. If I tell you that I'm going to give you 3 apples, but I don't have 3 apples, then I owe you 3 apples. That's what negative means. I owe you 3 apples.
Yeah, so it's just a concept, right?
It's a debit. That's actually how minuses actually originated from
bank loans.
Accounts. Yeah, bank loans and accounts. It was a debit.
So, like, if I had an apple made out of antimatter, would that be -1 apple, or would that just be an apple made out of antimatter?
Please.
What do you think, Brenda?
It would be the absolute value, because absolute value returns things to zero. So if you put an apple and an antimatter apple together, you get nothing.
Oh, okay,
But,
right. So
Dabin, Dabin, your second excuse was gravity. What's your problem with gravity?
What's that?
You had a problem with gravity like earlier.
What about gravity? Gravity
yeah, you said it wasn't real.
Gravity isn't proven. Even if there is a downward force, it doesn't prove a magical spinning ball. Simple as that.
Yeah, but why does gravity need to be magic?
What do you mean magic? Because we haven't proven
According to you guys, what is it that gravity does?
If gravity is true, the only thing it does is cause a downward force. That's it. You could claim it causes downward force. That doesn't prove a magical spinning ball.
No.
So
Gravity,
things go down equal gravity. That's pretty much it.
Gravity is the force of attraction between any two objects that have mass.
And you want to go on the Cavendish 1/500th million or whatever, 50 millionth of a friggin' it's still unproven. It's funny that y'all talk about us using friggin' old science when y'all want to use some balls in a shed that had no that couldn't. Matter of fact, they didn't have friggin' controlled air heating. They didn't have controlled anything back then. But yet you're saying
actually Cavendish controlled the air. He put the entire experiment in an unused shed, and he made observations with the telescope.
So they controlled the temperature. So that controlled the temperature inside the shed?
Yes, it did.
How did it control the temperature inside the shed?
That's what walls do.
Was he able to put warmer, cooler air in there to make it friggin' where the temperature stayed the same?
You just have to hold it constant. That's all you have to do.
And how did he make the temperature constant in that shed?
Dabin, can I ask you?
And what kind of tools did he use at that time that was so accurate?
Dabin, do you accept that mass attracts mass?
No, I don't see any evidence that that happens.
Nothing.
No, but I'm not saying it can't happen. I'm not saying that hasn't. But I don't think it's mass attracting mass. I think it's electrical, and there is charges where molecule or whatever they will come together more than they will or separate. I don't think it's the mass that's doing it. I don't think it's the mass at all that's doing it. It is the fields of energy that everything is.
Do you see those two balls? They're not attracted to each other. If I do this, those are attracted to each other. That's exactly the same as magnetism. What's the difference?
Well, that's magnetism.
Yeah, what's the difference?
Because you can prove that, you can't prove gravity.
What's the difference?
You can prove what's the difference. It's a different force. We know magnetism is there because we can do it. We can make stuff magnetized. We can magnetize it. We can't make stuff gravitized.
You can't
gravitize two balls and have them freaking orbit around each other or slam into each other or anything else.
So mass. It's the same thing.
So Tommy, he's saying that what he's talking about is kind of like magnetism, only different. Maybe like another force, in fact, that attracts anything, even metal or plastic or anything, to each other. Kind of like
that's a magnet.
What we call gravity.
Is it magic?
This is different size magnetic material. The force is the same. Mass is different. This one is easier to pull than this one. Exact same thing. Nothing different whatsoever.
Yes, there is a difference because you can friggin' demonstrate that. You can do it. You can't demonstrate gravity.
So what's the difference? It's mass attracting mass.
Wow, are you? I mean, according to this one, I just told you what the difference is. You can sit there and observe and recreate magnetism. You can't observe and recreate.
Can we say gravity is things attracted to the Earth?
Yeah, because that's the biggest piece of mass we have.
All right, cool. So that
doesn't necessarily correlate with everything pulling to the center, though.
It's the center of mass, yeah.
We can agree on things go down, and the Earth is pulling things, but what I don't agree on is everything pulling towards the center. I think things just go down.
Dropity.
Exactly.
Explain dropity.
Explain dropity. You pick something up and you let go of it and it drops to the ground.
Why?
Because you could say density right there in that front. It's density. Because it is more dense than the air around it. It is more dense than the air around it.
The why question is kind of like, what kind of answer you expecting? Like ask God? wherever direction our feet is meant to go, that's where down is going to be. So even if it would have been in the sky would have still been down.
Oh, that's a good one. That's a good one.
Is that density?
I don't know why you keep.
That's like moving your
phone.
phone.
I don't know why
right?
he keeps.
Why does it change?
Well, because he moved the phone.
Yeah, why?
Because he
probably
moved the
has
phone.
a gyroscope in there somewhere reading the level.
Yeah, it has accelerometers. It has accelerometers inside the phone.
How
That's
does the
affected by what?
accelerometer work?
What's
Do you
that?
mean the flat earthers know how an accelerometer works?
No.
You know, like what?
So you're gonna tell me it's detecting gravity? Is that what you're gonna try and say? An
No,
accelerometer
you
does?
can't repeat it as it is written in Google and the terms. We don't know anything according to
He
Globus.
did it several times. He repeated it.
You can do it. Anyone can do it.
How is that proof of gravity? Don't you think
What else
Einstein
can
and
they-
everybody else would have done
Explain.
would turn their phone or turn something and said, "Look, that's gravity." No, an accelerometer is not evidence of gravity. What an accelerometer does is sense movement. It senses your movement. Yes, it is.
Just really quickly, Damien, it doesn't sense movement.
That's how it knows that you turned your
Are you
fucking
ready?
phone because it senses
Are
movement. You
you
turned your
ready?
phone.
Okay, calm down. So an accelerometer or a MEMS accelerometer, you could go to the Bosch website and download diagrams right now.
Bro, there's a whole argument is fallacious. Yeah, Dean, you're about to get into a whole technical bullshit.
No, I'm not.
You do
This
in every
is
episode.
layman. No, this is
You're about to
layman.
confuse the shit out of everybody. Come on, come on.
matter.
This doesn't need to happen. This doesn't need to happen. This doesn't need to happen, Dean.
Gravity,
Wow.
gravity is not proof of a spinning
Jesus.
ball. Gravity does not prove a spinning ball. In the
So
story.
let me just finish this really quickly. A MEMS sensor is a micro-engineering mechanical device.
You do not need to explain it, Dean. You don't need to explain it. You don't need to explain it. You don't
So
need
it's
to
an-
explain it.
so
He
it's
does
an
this shit in
enclosed-
every
We've heard it all.
episode.
We heard it
Every
all
episode.
before. Yeah.
All right. So what causes those plates to move then inside the MEMS sensor?
You moving it? Will those plates move if you don't move the phone?
If you rotate it gradually,
if you leave that
incredibly
phone-
slowly,
if
with
you
where
leave that phone
friction
alone-
doesn't come into it, it will still measure a downward force.
If you leave that phone alone, will it start turning the friggin' picture so it's crooked and all that? No, it won't.
No,
You have to
no,
actually move the phone.
no.
Hey, Tommy, put your phone up and turn it really slowly.
Just a minute.
Yeah.
All right, Brenda. So sorry, go on, Tommy. First.
You can also use it in a car as an accelerometer when it's standing still in your car.
So a downward force is not conclusive of a magical spinning ball. I don't understand why y'all.
No, we're talking about gravity. We're talking about gravity, and these devices detect gravity. So, and we use it every day, and we use more devices.
All right,
that do
so
this.
I will believe you. Okay, so there is a downward force. There is a downward force.
Yeah, we call it gravity.
There is a
Yeah, I did
downward
drop
force.
this. Okay, yeah.
How does that prove the Earth is a magical spinning ball?
No, it doesn't. It doesn't prove magic.
The sensor is reading the programming.
Oh, it is a magic
programming of the cell phone.
because it goes against everything our reality tells us. It goes against all reality.
I would like to ask Brenda something about gravity because according to the mainstream science, the fundamental forces are carried by particles, right? For example, strong force is carried by a gluon. So when it comes to gravity, you guys have no idea how it works. I mean, it should be carried by something, but at the same time, it is the bending of space-time, and so nobody could unite on anything, and everybody has a different opinion. So why are we talking about gravity as if it will prove anything?
Actually, density and buoyancy can work on a globe also, so that's no proof of flat Earth either.
No, but Brenda, do you know the answer, or do we just have to let it be like that?
Well, what? Yeah. Well, we have detected gravity waves.
Well, but by what are they carried? Like, I mean, as I said, like all those forces are carried by fundamental particles. But when it comes to gravity, we have no idea. Like graviton, come on, give me a break. They didn't even claim to have found gravitons.
Yeah, there isn't a solution right now.
Yeah,
right.
The atom hasn't even been proven.
But
the most basic fundamental thing, the atom has never been proven. As a matter of fact, it was
Sure
coined
it has.
by
You
it was
can
coined
see-
by the same person, Einstein.
You can see atoms.
You show me where they seen atoms.
Just
Okay.
Google a photograph of an atom.
That isn't from the national. That isn't from friggin' the same government that's been lying to us about the magical spinning ball.
Okay. Well, whatever. Yeah.
Well, what? What do you mean? You're telling me to believe information from the same people that I'm telling you that are lying to us? What how does that make any sense?
Can I ask you something, Devin?
Wait a minute. Just don't do it with the U.S. government then. Do it with another government where we don't claim that they lie to us about science.
You ever heard about the New World Order? Well, let me tell you. That shit is
absolutely.
real. Yeah, exactly.
Absolutely. Except
the one government is the same as another government.
Except the problem with blanket assertions of my government lies, therefore every government lies. My government is controlled by the One World Order.
Then what would you call
therefore every government is controlled by the One World Order.
It is.
That's insane.
You don't even have to go.
Matter of fact,
Norway.
12 years ago, freaking Bush even stated this. President George W. Bush said, "We are creating the New World Order. The New World Order is going to straight from his mouth, straight in his."
Yeah. Norway is under U.S. government thumb. Sure.
Listen, if the New World Order was going to be created, it would have already been taken place. We could have done nothing about it. You know what I'm saying?
No.
Dabin,
I don't.
can we go back to the shape of the Earth? What could only happen on the flat Earth that cannot happen on the globe?
And how are we able to determine the results?
I mean, I don't understand that question at all. That sounds like
you need something that can only happen on a flat Earth.
How do we even know what's
How
in
do we see things?
We don't know what the sun is fully. We don't fully understand it yet. We don't know what it. You know what I'm saying? Its intended purpose. We know what it does, but what is it?
I think
trying to use it to prove shit.
How can we determine any of it?
Let's stick with one topic. Don't gish gallop.
I don't understand why flat Earth is so into freaking gravity these days. I mean, like for the last 2 weeks, I have heard nothing but gravity.
Because they have to give the term "things fall down." They have to give it a name. So they gave it gravity.
It doesn't prove nothing. Exactly, it doesn't prove a damn thing.
And since they want to correlate it with the shape of the Earth, they say things pull to the center.
Now, Groby's needs gravity.
That's what they're doing wrong.
Yeah,
They're
Groby's
correlating
needs
that
gravity
with
to
this falling
explain how
down.
you're upside down on a magical spinning ball. Flat Earthers don't need gravity. We just say things drop. That's the end of the story. You have to say gravity is there because they explain how water is sticking to a freaking ball moving 200 million miles an hour.
I can explain why gravity is important. It's because our observations of gravity are inconsistent with the Earth being flat.
How so, brother?
Yeah, exactly. I was just going to say that.
Because our observation of this mysterious, unknown, unknowable, completely magical force called gravity is that all objects, right, fall to the ground with the same speed. If it's a lead ball or if it's a plastic ball.
Only in a vacuum. Only in a vacuum, Brenda.
Yes. When you take away, when you remove,
and actually, we don't even know that because nobody's actually made a vacuum chamber large enough to actually prove that happens.
Yes, they have.
No, they have. You have to create a freaking vacuum chamber that's so tall that to be able to drop things because there's a thing called terminal velocity. Once it reaches terminal velocity, it stops doing. You can have the same
terminal velocity is because
shape,
of air resistance.
Because of. All right, so
I think I could be wrong about that. I could be wrong about that.
No, that's right.
You're right.
You would have to, but you would have to create a vacuum chamber tall enough for things to reach terminal velocity.
They would reach terminal velocity in a vacuum
That's what you say, but there's no vacuum chamber large enough to prove that.
Yeah, like it would always double, right? And so you would have to build it higher and higher, and at some point you have to build it so high that you couldn't maintain a vacuum because the building would just crush in itself, so you cannot prove it on Earth.
Exactly, that is another assumption. We're assuming that things will not freaking reach terminal velocity or whatever in a vacuum chamber. We don't know that.
Yeah.
If I drop this paper, it will fall slowly.
What do you think? What do you think causes terminal velocity?
What, the terminal velocity? It seems to be it's the mass. It's the mass that creates the terminal velocity.
No,
because listen. You have. I've already done the calculation. You could have the same. Listen, you could have the same shape, the same dimensions, but different masses, and they will reach terminal velocity at different things. No, it's not false. That is proven again over time.
You can prove it. You can prove it.
Hold on, guys. Let Schrodinger's and Davin for a few minutes because he was the one that asked the question.
Oh, okay.
And I want to hear Schrodinger's and Davin back and forth for a little bit.
Yeah.
Sure, I'm good with that. So terminal velocity happens because as something falls, the friction with the air increases. Once it reaches equilibrium with the force of gravity downward and the air resistance, once that equals equilibrium, that's terminal velocity.
No, because you can have, say I'm going to take 3 balls, same size, same shape, okay? I'm going to take 3 of them, but one weighs 10 pounds, one weighs 20 pounds, and one weighs 40 pounds. I take them all up in the airplane, drop them all off at the same time. Guess what? The one that weighs heavier will freaking hit the ground first because of terminal velocity. Once the first one gets terminal velocity, then the second one will hit terminal velocity, then the third one will hit terminal velocity. They don't hit it all at the same time. Yes.
Citation required.
Do the math on it. I've done the math on it. I actually sat there and did it for hours, freaking figuring out the CS freaking surface and all this shit and all this crazy stuff. You could do the math on it. Things that weigh that are the same shape and size, but different masses will hit the ground at different times.
No. I'm calling bullshit.
God, you seriously don't know.
if I have a lead ball, right, and a soccer, let's say a soccer ball,
Of
made
the
out
same size. Yeah.
Football for those on the EU, and they're all both of the same size. I drop them. They will both. One weighs barely a pound, and the other weighs, I don't know, 50 pounds. They'll both hit the ground at the exact same time.
No, they won't.
Exactly.
No, they
Yes,
won't.
They will.
Yes, they will.
Only so-called in a vacuum, but no, they will not hit the ground.
Just on Earth, I can just hold them up at shoulder level and drop them. They'll both hit the ground at the same time.
You're not going to reach terminal velocity by holding them on your freaking.
Terminal velocity has due to air resistance.
Because terminal velocity is when it reaches its top speed. That is when it is. That's as fast as it can go. So therefore, when you're dropping things off your hand, you're not reaching terminal velocity.
Yeah, that's unimportant though.
Right, and you still haven't explained what you think causes terminal velocity.
It's the mass.
The mass interacting with what?
I guess the ground. I don't know what it's interacting with, but it's the mass. Because you can have the same size, the same friggin' shape of friggin' things, but with different masses, and they will hit the ground at different times. It's proven over and over and over again.
You mean because it's heavier, it accelerates at a faster rate?
It will continue to accelerate past the terminal velocity. Say the soccer ball
per second upon its own weight, right?
Say the one's a soccer ball and one's lead, but they're both the same size and shape. That soccer ball will reach its terminal velocity way before the lead ball does. Therefore, the lead ball will outpace it and continue to accelerate while the other ball doesn't.
And the mass is interacting with what to cause terminal velocity?
My guess is maybe the pull, the resistance of the air. I don't know. I don't know. The resistance of the mass. I don't know how to explain it, but I just know that terminal velocity is what predicts how fast things will fall.
But you said you figured it out. You did the math.
Terminal velocity is actually the what terms things will stop accelerating. Once it hits terminal velocity, it won't accelerate no more.
If you did the math, you had the numbers.
The equation that you used to determine this?
Maybe a terminal velocity calculator.
So you didn't crunch the numbers.
Yes, I did crunch the numbers. This is why I don't have access to it right now. This is a long time ago. I did it on the Discord server, freaking probably 2-3 years ago, where I freaking crunched all the numbers. I did a 10-pound ball, a 10, 20, and 40-pound ball, calculated all the freaking things, and because somebody told me, oh, they're gonna drop at the same time. No, they won't hit the ground at the same time. And I calculated this, and they all hit the ground at different times.
What were the variables in your equation?
The only variable was the mass. That was the only variable, was the mass.
So you had,
the weight of it.
An equation with one variable.
I don't understand what you're saying. No, it's not one equation. You have to figure, there's multiple equations that go. You have to figure out the friggin' surface area. You have to figure out the friggin' all kinds of things.
They would have the same surface area if they were the same.
I know, but to calculate its terminal velocity, you need to know the friggin'. You have to figure out the first one and to figure out the other three. You have to figure out one of them and figure out the surface area of the friggin' of them. And actually, I take that back. I take that back. I didn't use a sphere. I used a square. I used a cube to do it because I was friggin' getting really flustered on trying to figure out the CS area of the friggin' of the sphere because it's friggin' major math that I wasn't friggin' keen to. So I ended up using a cube to demonstrate it.
Like a cube wouldn't work because there would be varying surfaces that are interacting with the.
It's hypothetical. We're not saying that the cube is going to turn, that it's going to do that. All of them are dropped straight down with a friggin' flat surface or whatever facing the friggin' Earth. You can do it yourself. This is not secret. I can't believe y'all don't know that friggin' term. You must not have looked up terminal velocity and tried to figure this out for yourself because, indeed, things will hit the ground different with the different masses. Same shape and size, but different masses will hit the friggin' ground at different times.
Other than your own calculations that you say that you did, do you have any citation for what you're saying?
Gavin?
Look it up. What do you think terminal velocity means? What do you think the terminal velocity means?
Didn't
and
I
why?
just explain what terminal velocity is?
Well, then you're answering your own question.
Davin,
Yeah.
would you explain this video, please?
All right. Get to it.
Yeah,
Brandon, I'm on here.
Where's the showing? I can screen share it too.
Like top right, those three dots.
Oh, you put them.
I got it.
I got you. All right, screen share. There you go.
Here we go.
Hold on.
Can you see it now?
No, I'm not presenting you yet. You gotta delete the Hangout link, and then I'll present you.
Delete.
Like cut,
Like
cut a few letters.
Oh.
Yeah, just click it and you can put it away. Like, but we cannot see the Hangout link, right? Anyway.
Okay, so it's deleted now.
There you go. Yeah, you're up.
Perfect.
Now I'll present you. Yeah.
Okay, so here it is. This is one of these is a very heavy ball. The other is a basketball. Which one is going to hit the ground first, Davin?
Let me see. Are you showing it? Exactly. My point. Because
which one's going to hit the ground first? One is very heavy. It's a medicine ball.
You're not, okay, I understand what they are, but let me talk. I'm going to tell you again. Like I just told you fucking 10 minutes ago. You're not letting these things reach terminal velocity. Yes, everything.
Which one's going to hit the ground first?
Everything reaches but if you take them up in a goddamn airplane, they're not going to hit this at the same time.
Which one's going to hit the ground first?
Neither. They'll both hit about at the same time.
Yeah. Why is that?
Take them up in an airplane and watch which one hits first.
Here we go. Oh.
Take them up in an airplane and show me this. Take them up in an airplane and show me this. Oh, wow, look at that one. What happened there? Oh, they cut that one off, didn't they? Because clearly.
You should watch. You should watch a video yourself because it really lags when screen sharing. So just search it, or you can even post a link in the side chat.
I stopped sharing.
Brenda, by the way, stop playing ESO while while talking.
Thank you, Brenda.
To other people.
What I'm doing? Come on. You want?
Here you go. Here's somebody.
Okay, while you're trying to figure that out.
Really quick, I'm sorry. Yeah, I always interrupt the wrong moment. James Mays and others, if you want a Hangout link, just send me a message, a direct message. I haven't looked it up, but I'm gonna look it up now. So if I got anybody that sent me a private message, my username is in the description box on this video. So type in that username and then send me a quick hello, and I'll send you the link. All right. Carry on, guys.
All right, this is from Britannica.com. Terminal velocity is achieved when the speed of a moving object is no longer increasing or decreasing. The object's acceleration is zero. The force of air resistance is approximately proportional to the speed of the following object. So the air resistance from the object that is accelerating, having been dropped from rest until terminal velocity is reached. A terminal velocity air resistance equals in magnitude the weight of the falling object, because the two forces have reached equilibrium. That's exactly what I just told you. So there's my citation. Where's yours?
And here you go. I will screen share. Here's my calculations that I did in a graph here that I will show you that each one reached terminal velocity at a different speed.
Hey, hold on. Talk about it, but I'm not going to be able to present you just 1 minute. I'm sharing a few links.
Okay. Okay, gotcha.
I have a question until it gets sorted. Like, does everything fall at the same rate in a vacuum? Everything?
Yes.
Even air molecules?
There's no air molecules in a vacuum.
Like, obviously, if you let a hammer or whatever, or the feather drop, but let's say a almost complete vacuum, and then you are going to take an air molecule and let it fall down. I mean, obviously, it would be almost a vacuum, but not completely. So would an air molecule fall at the same rate as a bowling ball?
Dabin, before we continue, can I just ask where you live?
America, New Mexico.
New Mexico, around what city?
Right outside of Santa Fe, about 10 miles outside of Santa Fe.
Thank you. I'll be preparing something.
But anyway, good catch with the air molecules, that there are no air molecules in a vacuum. But like there are always some molecules, right? But anyway, my point was, if you go if you go smaller and smaller than the air molecule, at some point you will hit. At some point you will have things that are uncertain, the position of them. So you don't know the position, and you don't know their direction, etc. So you don't know how fast they fall. So not everything falls at the same rate in a vacuum.
That made absolutely no sense. I don't even know. That's not even wrong.
So what the other thing is like, if gravity would be like they told us, how does it come that there is a lot of air in the atmosphere? I mean, like the space between the air molecules is so huge, so there should be a really, really thick layer of air lying at the ground, because gravity would pull it down and keep it there instead of making it fly around.
It's called air pressure.
Yeah, but it would be way more than 14 psi, because the air above should
determine that.
Because the air above should have space between the air molecules, so there should be a really, really thick layer of air, which we don't see because
we do. It's a pressure gradient. How do you not know this?
No. I mean, there should be way more pressure down here if gravity was as they told us.
Yeah. And how did you determine that there should be more air pressure?
Because there is a lot of space. I mean, the air molecules, they almost don't interact with each other.
Sorry, Zinder, is well done, by the way. Is gravity a weak force or a strong force?
It is. I mean, it's supposedly so strong that it can hold.
No. I mean, how do you classify it? You've already said it about 3 times in this hangout. Is it a weak force or a strong force?
Like I talked about the strong nuclear force, it has nothing to do with gravity, and gravity doesn't get.
Yeah, and electromagnetism and gravity. What is gravity classified as? Just tell. Is it weak or strong? I don't know. I'm not a scientist. Let me know.
Well, like if we don't even know what it is carried by, so how do we know?
Okay,
it? Because,
another question then is gravity based on the center of mass at the highest intensity at the surface of our planet, is that very intense or very weak? And when we go to the upper atmosphere, by what percentage does that change in force versus the altitude?
Well, it doesn't change, like almost.
No.
It almost doesn't change because like supposedly gravity is divided by r squared, and so the farther away you go, the weaker it gets. But
yeah,
so the air molecule should be there where the most gravity is at the surface. They shouldn't be in the air up there. That makes sense.
Right. It's called a pressure gradient. We have a pressure gradient in our atmosphere caused by gravity.
That still makes no sense because I just disproved your point.
The odd thing, Zinder, is the air density and that pressure gradient match with the fall off of the Earth's gravity force based on altitude. So at 250 miles above the surface of the Earth, there is 85% gravity force than there was at the bottom, and it is that simple. It's a weak force, and it dies the further away you get. Thus responsible for the gradient.
Well, you always claim
it. The 4 fundamental forces.
Yeah, like first of all, we have no evidence for the fundamental forces, and second, there is how is it weak if it can hold the Earth to the sun? It makes no sense.
Do you know what a barometric altimeter is?
And pull the moon towards it.
Yeah, right. Even that moon.
Zinder, you said something there. I've got to pull you up on it though. You said there's no evidence for any of the forces. Do you want to revise that?
Yeah, I made a presentation about the 4 fundamental forces.
I missed that actually. I actually did miss that. I meant to go and look at it actually.
And can you answer my question? Do you know what a barometric altimeter is?
It measures the pressure on a. It measures the air pressure or water pressure, whatever, where you are, and then it tells you the pressure of like PSI.
So yes, aircrafts use barometric altimeters to tell their altitude. If there's no pressure gradient, how does a barometric altimeter work?
There is a pressure gradient. That's my point. There shouldn't be a pressure gradient as we see it if gravity was a thing.
Why not?
Because there should be a lot more air where I'm standing right now, and there is a lot of space between air molecules. But if gravity would act like a well, everything should fall down that well, including air, and it would just stick there at the surface.
Again, that's not even wrong. It's so off base that I don't even know where to begin. That doesn't make any fucking sense.
Then I'm right then.
Long live the strong force which gravity is. You know what? I see this as an
Yes,
interpretation.
you are right because it made no sense.
Yeah, because if I believe myself, I'm strong and I can take anybody. I'm strong and gravity hold me down, so gravity is stronger than me. So gravity is a very strong force. Shout out to my nephew, Gamer Herrick. I'm gonna put the link in here, helping out to get to like 100 subscribers. He is like 15 away. Carry on, guys.
Yeah, so Jose's statement.
You better play more than just Fortnite.
Watch him go up a ladder. He can beat gravity that way, really easy. Watch him jump in the air, he beats gravity there. How strong is gravity if you can just defy it really easy?
Well, it is supposedly strong and weak at the same time. So we already have the strong and weak force, but those are nuclear forces, which
why is it supposedly strong?
Well, because when I fall down, right, I break my head, which probably has happened before.
I shouldn't laugh at that like that. Jesus, no.
I think we've identified the problem here. You fell down too many times.
I showed you this earlier. This is big. There's big J and little j. The bigger number little j is, the bigger the force. It's not much anything. Yeah, that's the same thing. Big J, little j. That's it.
How can we equate that to the shape of the Earth?
We cannot.
Other than things fall down and things are attracted to the Earth.
Well, if gravity is a thing, and the reason why flat Earth can't accept gravity is there will be in physics
Don't speak for us. We never said we don't accept gravity.
All right. Well,
we say
whatever you do.
A lot of you don't.
That it don't pull to the center.
All right. Yeah. No, a lot of you don't.
So
if gravity is a thing, then there would be a terminal mass of which it would collapse into an efficient shape, and the most efficient shape that can be formed is a spherical object.
Right.
Logical fallacy.
How?
No, that's a ball has the maximum amount of
because
static
it logically
equilibrium.
makes sense, right? But then when you start thinking that there are people upside down and it's raining from the bottom up.
You said it was a logical fallacy, and then you said logically it makes sense.
Logically, it makes sense that it could be a sphere. Logically,
it's not a logical fallacy. Then
raining upside down, that kind of doesn't register in the mind very well.
What do you think up and down are?
So wait a minute, just really quickly, Matrix, in order to criticize a system such as a heliocentric gravity-based world, you would have to understand it. In our reality, the center of a ball pulls everything towards it, which means walking around that ball, the only direction up is away from the center. There is no upside down.
But this is the debate that is going on determining these things. And in your model, certain people on the continent are one side, and other people are completely opposite from them.
Yeah,
what you guys are saying is going on.
Yeah, so there you go. In Australia, up to someone in Australia is a different.
So where would it be raining from? On that side of the continent? Wouldn't it be from the other side?
Let me finish. So up to an Australian compared to where I am in the United Kingdom is a different 3D vector in our reality. We both call it up, but theirs is pointed almost, I don't know, 130 odd degrees different to my up, because down is always to the center of the ball, up is always away from the center of the ball.
I disagree.
So that's
all about reference frame.
Oh, okay. Go on. Sorry.
I got it on screen here.
You can't use Zinda. You can't use rugby balls or American footballs as any example.
Okay, I have another thing. Regarding it, so you claim that the center of the Earth is the center of gravity, right? So
center of mass of an object is
okay. So like if you guys claim that in the middle of the Earth, like everything is attracted to the middle of the Earth, but that makes no sense on your heliocentric model because that would be completely contradictory. Because we have the moon, which creates a the center of gravity would be a little bit more towards the moon, and then we have the sun, and that should be measurable, but we don't, because otherwise, if you would be at the other side of the Earth, the center of gravity would be a little bit more away from you, and so it would be weaker, because the more you go away from the center of gravity, the weaker it gets, and so you should be able to measure it.
Yeah,
Right?
so Zinda, really quickly, if you accept this assertion that we have measured gravity at 250 miles and measured from the surface a 15% drop in force, what would that be at 250,000 miles against a weaker mass, which is the moon? You could do the maths on this yourself and work it out, and you'll see that it does affect us, but very, very small.
No. My point is that the center of gravity isn't always the center of Earth, according to the heliocentric model.
No, center of mass of a reference object, which is the Earth and the Moon. They are not one.
So why do you guys always claim that we are getting pulled towards the center of Earth? We are getting pulled towards the center of gravity, which would be the well which everything would have to fall in. But we don't experience it, because otherwise gravity would get weaker and stronger. Would feel weaker and stronger the more time passes, and that doesn't happen. And the moon is claimed to move away, and so the gravity should decrease, but we don't measure it. So that's complete bollocks.
This is brilliant word salad.
I
got
a full panel. Let me introduce everybody. We are currently joined by Artrexis, Brenda, Davin Good, Matrix, Schrodinger's cat, Stingray, the Rumpus, Tommy, and Zinder. Thank you guys for filling it up. Carry on.
Thank you. Does anybody have any balsamic vinaigrette that I can have to go with that word salad?
That was brilliant.
Can I ask Dabin one more question, please? Do you believe in that flat Earth model where the sun is about 3,000 miles up? Is that your belief?
I have no belief in that. I don't know what the sun is, where it's at, what it's doing. I have no. It's all theory. But yeah. I can tell you that I do believe that it is a lot closer than what they. Of course, it is a lot closer than what they say. It has to be.
That's not what the word theory means.
What do you mean theory? It is a theory.
And when you say it has
you cannot prove the size or shape or anything about the sun.
Oh, why not?
What do you mean why not?
Why not?
Tell me how you do this.
I got this.
To calculate the
Tommy's got
wait a minute. Okay, let's start with the distance. To calculate the distance to the sun, you have to assume that Earth is moving. Is that true or not?
Dabin, I got this. Please, can I continue? You lived in Santa Fe, that's about here on the globe. That's on. I'm going to go back to Google Maps.
I thought somebody asked me a thing, and then they want to talk about the sun, and then I do it. Now all of a sudden you're off somewhere else. Wow.
Yeah, just keep track on me, please.
Hey, we're still talking about the sun. Settle down, dude. Settle down.
Just to understand what model you believe in.
People were just talking about the sun. You asked me a question about the fucking sun.
Whoa.
Yeah.
Breathe.
It's just to understand what model you believe in. Nothing else than that. I'm going further. Please, just stay with me.
Y'all talk to yourself. Fuck y'all.
Yeah. From Santa Fe, you live on the 35th degree. And on the flat Earth, if you live on the 35th degree, that is 60 degrees of the Polaris. On the globe Earth, on the 35th degree, that points directly towards Polaris. That's my thing. That only happens on the globe. That can't happen on any other shape than the globe.
Tommy, the only thing you need to prove that is the sextant.
Just really quickly, Tommy, what would be good is if you could do another example of that. I was thinking of doing one where you don't have the Polaris observation, but you have the sun at a certain date and time.
I think Fight the Flat Earth is going to do that very shortly.
And Slice Barcane already did it with 23 participants.
Yeah,
around the world.
And Fight the Flat Earth is going to do that in July. And actually, I'm going to show.
But I heard they say that the best explanation for the sunrise, sunset, and how the sun behaves, how high it is, and all this stuff is in the Antonio Suberat's Book of the Sun. What do you think about it?
Dabin left.
He rage quit.
Well, you guys were really rude to him, and I think you should be you should stick to the topic first of all.
Zinder, you're a flat earther. Can you explain to me why the sun isn't affected by dropity?
Well, the sun isn't affected, because when it comes to the sun, we don't know what the sun is. So like the same way, the same way, like why aren't photons according to Einstein, like gravity sucks in photons, but photons are almost not influenced by gravity. So the same with the sun when it comes to dropity. Probably it isn't. It is just a concept. I cannot explain it very well, but I'm gonna research into it. And I think at the end of the day, we don't know what the sun is, so why should it be affected by dropity or whatever you are going to call it, which isn't even a term.
Zinder, really quickly, if you can't explain what the sun is, does that mean you refuse to look into it? Until you can.
It means he's not satisfied with the explanations given by your camp.
No, it's just a question. So
and the same with the distance to the sun. Sorry, gone.
But I mean, can we assert that there is an object there and it emits energy in the form of light?
Yeah,
and heat.
But
we don't know.
Heat is energy.
Right. So can we also assert that we can put a solar filter over a lens and we can see a physical size, thus bleeding out all but 0.1% of light, and we can see something solid? Is that correct?
Look, I know where you're going with it.
How do we determine that it's physical, though? How do we determine that?
Okay. I'll take away the word
so you can see it.
I'll take away the word physical and I'll just put a solid shape in its place.
Were we talking about the distance to the sun?
No, we're just we're just talking about the sun at the moment.
Well, Dabin said that everything about the sun was theoretical, so that would include whether or not it's actually a 3D object, as well as its distance.
Well, at the moment, I'm just asserting that it's a solid shape in my view, and that's it. So, Zinder,
we can harness the energy from it.
Can we agree that it is a solid shape in my view, Zinder?
Well, if you want to go with that with that path, I'm gonna follow you. But at the end of the day, we cannot draw any conclusions from it. But please.
So we can't determine what it is, but we can observe it. Therefore, I'm saying, is it valid making an observation of what we see, or do we have to disregard it because, let's say, you and I don't know the makeup or what it is, how it came into being, and all that? We can't track it. Do we just disregard it?
We determine that there's something up there, but we cannot conclude the shape of the Earth from it.
No, I'm not on about the shape of the Earth at the moment.
What the sun is?
Not only we don't know what it is, but we don't know what happens with the light that leaves the sun, right? We don't know what happens to it.
Right, and that's.
We can harness the energy from it by solar plants like this one and this one and this one.
Yeah,
you can't do that from the air. There's mirrors to direct the sunlight to those plants, and we harness the energy from the sun. The sun is not a projection.
So go on, Dean.
So, Zinder, what's your best explanation for why this object, when it moves, does not change angular size?
Well, I mean, it could just get bigger and smaller.
Okay, that's brilliant. So now when you observe that it stays the same angular size, and no matter where you go, that is a universal constant around the land masses on this solid thing that we are on, then can you conclude anything if it doesn't change size?
I cannot conclude anything. I mean, it could just be farther away than those 4,000 miles, but it probably is way closer than the heliocentric model says. Because when you try to measure the distance to the sun, you don't know what medium it travels through, because we haven't proven that space is real, or whatever space is. And so since light refracts, diffracts, etc., and we don't know the medium, so we cannot measure the distance to the sun by just shining radars or whatever.
Refract all the things.
So we have a problem. We have a big problem, because Einstein claimed that the speed of light is constant, but as we see, the speed of light slows down when it travels through water and air. And so we don't know what space is made of. So
he said it was a constant in a vacuum.
Have you any evidence for it?
You can measure the distance by trigonometry.
Like,
Yeah,
what
well,
is a vacuum? We don't even know what a vacuum
Tommy,
is.
yeah, no, Tommy, that was my next point. But the error tolerance of doing it from a ground base would give
Yeah, it's
you
a sharp angle. Yeah, no.
Yeah, but you could determine with trigonometry from different viewpoints that the sun is either this magic blob that exists in reality that changes shape and size and is completely dependent on the person viewing it, that somehow also correlates to the angles to everybody else, but magics its shape, or it's incredibly far away.
Look, Rumpus, you just mentioned a vacuum, and come on, dude, we. According to mainstream science, a perfect vacuum doesn't exist. Particles, like those holographic particles, they just appear, they go away, and they come back.
Particles?
And yeah,
What are
virtual particles. I mean, they annihilate each other, and so there is no vacuum. So we don't know how fast light could travel.
Cinder, if you see my screen here, this is my flat Earth model with a grid system. When Fight the Flat Earth is doing his Aristoteles project, I'm going to punch all those coordinates into this grid, and every one of those lines are going to point in every direction all over the place. That can only happen on a sphere Earth. I'm going to debunk the shit out of this one. Trust me.
Oh, look, you just assumed how.
No, not assuming.
Dude, come on, that's not even a real map. Give me a break.
Show us the real map, please. That's what we're aiming for. Everyone is waiting for the real Flat Earth map. Please show us.
Would you guys say that that's the real sun in my little box there? Would you guys say that that's the sun?
I mean,
how could you explain that on the top of it isn't bright up?
No, that's the light of the sun. Within that light, it sits the solid shape of the sun. Yes, but we can't see the solid shape here.
So what you're saying, what you're looking at through a lens, are you looking at through a lens? Is it that object? Isn't that what we're seeing right now?
Well, no. When we cannot see the object, which we classify as the sun, we can see
Glare
the emitted energy. Yeah. So you would. We told you this before, Matrix. If you get a solar filter and do the same thing, you would be able to see the sun. You'd be able to see the shape of it.
But theoretically, whatever we're
that.
measuring, are we measuring this and not a giant ball 98 million miles away? What?
Well, with the filter, you're able to at least discern that there is an object in there in the glare. I mean, that's the first step. And then from there, you can move forward into figuring more shit out.
I agree. We all agree that there's something up there. It goes from point A to point B. We can all agree on that. But to determine its distance into what it does and what it is made of.
But okay, so we see the filter and we see the object that's there through the filter. Then we go into, okay, well, throughout history, throughout our basic understanding, we can know that the sun, it's emitting light and it's also emitting heat. So we have to discern, well, do we know of any other object or phenomenon where something that doesn't exist or something that's a projection can also project heat? And as far as I know, I don't think there is such a thing. So we can therefore make an assumption. We can confirm it. We can make an assumption that the object is at least three-dimensional, because we don't know of anything that's not an actual 3D object that emits heat.
There is the key, though. We don't know, because you're currently on one model, right? Have you considered another model? Have you considered how it might be working when there's
tests and observations to discern?
Or maybe there is a ceiling. Maybe there's a ceiling. Maybe there's a top part.
What?
That's conjecture until you do something to confirm that.
And we can also
when
use
we look up,
spectroscopy.
all we're seeing is the sky, the blue, the light blue. We don't
Okay.
really know when that ends, or we just seeing. You know what I'm saying?
Yeah, until we put rockets and satellites up there, and we don't
and you don't see the fallaciousness in that, and putting. Isn't that the whole argument that people are not doing those?
You put
things?
something in orbit, it doesn't hit anything. Ergo, there's not a freaking glass ceiling above us.
How are we going to put anything in orbit if we're still debating if there's a space, if it exists?
No, we're not. You're debating.
No, Matrix. Everybody else on this panel that isn't a flat earther knows that the flat Earth is a bit of is a strange concept, and we're here because it's really interesting, and we probably all like debate. But as to whether we need to prove it now. as to whether we need to prove it, there's a certain time in civilization and advancement where when you fly away from something and look back at it, you no longer are concerned with the shape of it because you can see it. And there's many, not just NASA, many space agencies that have done this. They've flown away and looked back, taken photographs. It is that simple.
You guys don't even know the shape of the universe, and we always look at the universe, so that's completely a false claim because the universe is everywhere. We don't know the shape of it, and you just claimed that we know the shape.
You're right,
and that
Cinder.
it's ever expanding.
Yeah, no, you're right, Cinder. The universe isn't a solid object. So yes, I would not want to hazard a guess as to the shape of it because I'm not even sure how to classify it. However, the planet is pretty much a decent geometric shape that I can determine is a sphere when we look back at it.
Well, we don't even know what matter is, right? So,
oh, for Christ's sake. So any flat earther on this panel, any flat earther anywhere can determine the shape of the Earth. There's a company that will take you to 60,000 feet in a MiG-29 aircraft, and they guarantee that you will see curvature, or you get the flight for free.
That should be anyone's bucket list.
You got that MiG-29 money?
From what distance? From what distance are you able to see the curvature?
They go between 60 and 70,000 feet.
I did it from 70 feet.
These things don't correlate, man. You people keep changing the post on when you're able to see the curvature. It's always a different amount of altitude required.
Matrix,
Matrix,
really, Schrodinger just said something there that is amazing because it means every flat earther that is pretty sure the Earth is flat gets a free flight in a MiG.
Yeah,
fulcrum.
man, just like that.
Matrix.
Hold on, I'm not done. Yeah. There was supposedly this airline or boat service that took you to Antarctica. You guys remember that fiasco? And all the Globers was like, "Yes, this is happening. You could just go charter." And one guy did it, and he managed to steal everyone's money because it didn't happen.
No.
Greater Sapien. Anybody remember that fiasco? Huh?
I donated to Greater Sapien for that.
And he stole your money because he didn't go anywhere, did he?
Realized it was a scam.
Matrix.
Exactly.
The difference is how
what you're saying smells like that exact bullshit.
No. The difference, Matrix, is one of those is to take. Yeah, one of those is to take advantage of flat earthers. The other is actually a commercial enterprise that people do. And
whenever any flat earther does it, post your pictures up, post your details. Until
Matrix.
that is not going to be used as a
$20,000 ring laser gyro that FE Core bought.
Yep, that did a pretty good job. And we can also.
Matrix. It depends on what kinds of observations you do. With our own eyes, we need to go high up to see the curvature.
Yeah,
when you have this one, you can go lower.
Has something to do with it. Optics has something to do with it.
Yeah, of course. When you have your own eyes, you need to go higher. We cannot see curvature with our own eyes standing on the beach.
Do you understand the concept that even if we was as high as we could possibly be, I don't think we will be able to see the entire Earth in itself. You guys
did this one from 22 meters.
Okay, but that means that you are basically abject denying all images from low Earth orbit and space. And
no, just because I understand that possibly we're not even able to see it from. Doesn't matter the distance. It just doesn't mean that I can't conceptualize that it's a certain shape. It's too different.
It's the way you do it.
You guys are using things that are in the sky to determine.
Sound? No. Sound did it from the 15th floor. I did it from 70 feet. If you want to use your own eyes without optics, you need to go higher. That's your perspective.
With his footage, he doesn't convince because there are optics, there is temperature, there's different things at play. One footage doesn't determine when there's other footage that shows going over supposedly over curvature, and then we're able to zoom back into it. Which
but the problem. Matrix.
Doesn't we know that cameras don't go over things, right?
You're getting,
So
you're
how
getting,
do we
you're getting. You've got a mistake there in the fact that there is a huge difference between the angular size reduction in something down to infinity where we can't resolve it anymore versus something occluding or obscuring, as in geometry occluding or obscuring. Now, yes, you can zoom out. Wait a minute, let me finish because you showed a video. You can. No, wait a minute.
Don't go into terms.
So when that boat, goes.
You guys are trying to
okay, I'm terribly confused. Let me tell you about my confusion. So when the boat goes into the distance and we can no longer see it, and you say we can zoom into it to see it again, that is correct. However, when the boat goes over the horizon and it is occluded by water, no amount of zoom, since all that zoom does is it makes stuff bigger. It does not alter perception or perspective. That's not how optics work.
This is not an optics conversation. You guys claim that
you brought it up. The last 10 minutes you were talking about optics. What the hell?
No. What I'm saying is my point. He's trying to use my point against me and turn it into an optic thing. What I was saying is you guys use the excuse that the boat is going over physically, the physical curve, curved, but somehow we're able to zoom into it. That doesn't make any sense because we know that cameras don't zoom into curves.
No, like I said,
okay, so maybe they're going over the physical curvature. Maybe that is not the thing. Maybe it's just flat, and you guys are excusing it away.
Okay, so do you make the assertion then that if a ship is obscured, and I'll get one up now. I've shown you this before. I've got a genuine question for you now. So this ship on the right, on mine, are you saying that if I zoom into that ship with a longer focal length,
P1000?
Yeah, that's a terrible camera.
Yeah, no.
If I zoom into the ship on the right, are you saying I would be able to see the bottom of it?
Do we all know the distance to this?
9.9 nautical miles. But that distance is irrelevant. At the moment, it's occluded. Now, are you saying that me zooming in with a lens is going to bring that ship back up over the horizon? Is that your assertion?
I can't tell you what zooming in would do. What I could tell you is that camera is clearly focused on a certain point, and everything else is focuses on that central point. Right.
So a camera has what you call a focal plane, not a focal point.
What I'm saying
a plane, a virtual distance away from that lens is in view, and then the focal the focal point of that shifts, or the focal intensity shifts in a fashion depending on what the aperture is. So that's actually relevant. So all I'm asking you is, if I turned the camera to the Hunagayan Spirit and zoomed further in, so let's assume this is 2,000 millimeters, but let's say I had the option to go to 5,000 millimeters, because the effect gets exponentially less the further down
what is the distance?
9.9 nautical miles. So if I zoom into that with 6 foot. So if I zoom into that, are you saying that it would bring it back over the horizon? It's just a yes or a no question.
Listen, I can't tell you what you would do when you're not presenting me the options to. I can't hypothesize. You know what I'm saying? I'm not a freaking AI.
Okay.
Same with my win.
You were making very definitive statements about 10 minutes ago, and now you're kind of.
No, what I'm saying is this. I can't give you any details on this because this is just one photo. What I could show you is a bunch of videos of both supposedly disappearing over what used to be the example.
Yes, but they're not over the horizon, are they? Those boats were not over the horizon. Look at my picture. There's some wind turbines here. Do you think zooming into those pictures will reveal the bottom of the wind turbines?
Again, these are just pictures.
Yeah, these are just pictures, exactly.
You know, temperature, altitude.
The question on the table is, do you believe that zooming in will reveal the bottom of the wind turbines? Yes or no?
And can you zoom my wind turbines back over my eye level? You need to make them go back over my...
You've gone quiet, Matrix. Why is that? I wonder.
Nah, man, I haven't gone quiet. This is what you're asking me.
I'm asking you if you think the picture that I've got up on my thing of wind turbines, if you zoom in, they will. By zooming in, you will reveal the obscured part of the wind turbines? Do you
I
think
don't
so?
know.
You don't know. That's convenient.
Details. I don't have any details. It's just a
What
photo.
details? What details do you want?
What should I determine from one photo? What is it that you're trying to make me determine from one
I
photo?
got another photo. That's 2 photos.
I can give you lots of photos like this, Matrix.
Wait a
What
minute,
details
Rumpus.
do you want?
Rumpus, Tommy has got the best examples to demonstrate this point that you will actually see, and I think
Have
you
we?
two ought to
Okay.
talk. Yeah, no, because he's done observations, he's done measurements, he's leveled the camera, he's shown that the horizon isn't there, even though the turbines in the distance are actually 300 foot. The base of them is actually sat on something that's 300 foot high.
500.
Yeah, 500 foot high, but they're below the horizon, so it's even better than Al-K's images.
Below eye level.
Yeah.
What are the wind turbines? So the wind turbines on ground, are they?
Yes, they're on here. This is Norway and this is Sweden. I'm standing here at the end of the world, and those windmills are here, about 46, 47 miles away. And I have my setup here and shooting across the eye level, and that's my eye level. Those 1,000 feet to the top of those windmills, and those are below my eye level at 70 feet.
Those are clearly
So-
CGI windmills. Come on.
Yeah, sure, obviously.
How far?
You can see them back here.
How far
Zooming
away
in
do you
doesn't matter at all. This is 24 or 70 millimeters.
How far away?
This
again
is
are they?
400 millimeters.
How far-
46, 47 miles.
And
Oh, they've got a bit clearer now. Right, I thought they were a bit blurry, but yes, now you stopped doing it. Yes, they've become a bit clearer now. That's good. Okay. Very nice.
One thing I try to ask, and for me is this concept of if you see a boat go over the alleged curve, and then if you put it, zoom in a camera and you can see it again. Okay, so if we take the premise that the sun is just like traversing across the sky, above us over this flat Earth, why doesn't zooming in after the sun supposedly sets, do you not see the sun again? Like once the sun goes below, supposedly goes below the horizon or too far away for our eyes to see, why can't we take a camera and zoom in on it and then get the sun back again?
Did you see the observation that I think it was Red Rhetoric did it with 2 side-by-side cameras, one with no zoom, one on max zoom, and the sunset.
Sean Hoffer did it also.
Yeah, the sunset at the same exact time on both cameras.
Yeah, and Sean Hofford had that with the drone going up and down. He had 7 sunsets following each other.
Yeah, that was a good.
I never saw that video, but that's just one of those things I asked, and I never really got a good answer for it.
Hey guys, Chris jumped in a few minutes ago and he haven't spoken. I want to give him the chance to present or speak. I see
How you
you're
doing, Chris?
presenting Red Pill Philosophy Buildings. Talk to us, Chris.
Yeah, I mean, so all these claims about curvature are easily explained due to refraction. So when Rumpus has these windmills that show about half cut off, well, here we have a 12-story hotel that's half cut off, and in the top image, in the bottom image, you can see the top 3/4, and then from the top of the tree line to the bottom of the water.
I've got a question
So here in this image, let me finish, Dean. So in this image, you can see the entirety of the picture, and in this one, you can only see half the building, and it's the exact same phenomenon that Rumpus is showing.
Right, so my question is quite simply this, Chris. Are you drawing conclusions from those images?
Yes.
Can I assert that buildings use straight lines predominantly in construction for rigidity?
You can assume that, yes.
Okay, brilliant. Can you show me one of those straight lines for me from top to bottom or laterally?
Oh, you just got schooled, son.
Just draw it on there, it'll be fine.
Well, this isn't. I don't know how to use this one. Here, let me.
Oh, just point to one. Point
Here,
to a straight
hold on.
line.
Hold on.
Okay.
That's a mic drop moment, Dean. Well done.
No.
Air
No.
There.
The building. The thing that
Well,
you're
the water
pointing
line is
to.
straight. The water.
No,
Straight.
the thing that you are pointing to. Why am I seeing lateral shift in construction of that, left and right, probably in the top image, probably about 3 or 4 feet. But when it gets to the bottom of that top image, loads of feet. Those are not straight, and you are delusional if you think they are. Look
I
at
don't
the
know what
one.
you're talking about, Dean.
Do you not? Give me that image.
It's not supposed to compress in a perfect form. The atmosphere is at play here, and you know.
Right, awesome.
There
So
are
if
other
the
factors.
atmosphere, awesome. So if the
What is your
atmosphere is
point?
compressed,
What is your point that things are not straight?
So my point is, if there are no straight lines on that building, if we can see that compression is happening and balconies are at different size, what fucking reality are you looking at when you say this is reality? Because buildings are not built like that. You could draw no conclusions from that other than, hey, look how much this is
That
distorted
looks
through
fairly
refraction.
level. That looks fairly level. What are you talking about? It looks like it compressed fairly even.
So right now, this is flat Earth delusion. Prime example to anybody listening. Just look at those lines waving around, the up and down lines that should be straight on a building construction or else someone would get fired. And they're wavy. They're all over the place. And I guarantee you that if this was a video and not images, that building would be pretty much jelly. And they do not
So
make
your
them that way.
conclusion is photography is not a good
No,
determining
my
factor?
conclusion is simply this, and I assert
Let's
this.
test that.
Looking
Let's
at
test that.
something that does not represent reality due to the
Let's
fact
pull up
that
the
it's
video,
waving
Dean.
let me finish.
Pull up the video.
Yeah. Looking at something that doesn't represent reality and then drawing conclusions from something that doesn't represent reality, you are not calling on reality. So it's a fantasy world you're living in.
Okay, let's pull up the video and see if it's moving about.
Couldn't we say the same thing about, you know, the whole sphere and the planets and the galaxies?
If I point to you and say, hey, look at this, this is reality, and the damn thing is waving all over the place, you say that to me. Absolutely.
I can show it here. This is atmospheric lensing. On the right side, you have lensing. You have compressed the bottom part. On the left side, the building is going down to the bottom. We don't see. This is what you see, compressing. That's atmospheric lensing. And then it gets distorted.
Do you mind if I
That's how it
present
works.
for a second?
I'd rather you didn't use the term atmospheric lensing, Tommy,
Yeah,
because it's
I
not
know.
lensing. It's
Yeah.
Compression.
Compression,
It's not
yeah.
lens. It's not acting like
Oh,
a
you're
lens.
pretty good. You're pretty good with that program, right, Tommy?
Yeah.
Have
Used
you ever
Unreal
tried
Engine.
design them some sort of a flat model?
Yeah.
Hey,
I got
look
it.
okay, I'm presenting
Unity.
the video that this bottom picture came from. Let's look and see if we can see any dancing buildings.
After you present, Bob wants to present something, Chris.
Sure.
We're
I don't
presenting
see anything dancing so far.
Well, no, the buildings.
Who was the one asking about model?
So go to the buildings, Chris, and give me the link to that. I'll rip it and I'll show you.
I didn't catch who one was asking me about my models. Who was
Oh
it?
my goodness, would you look at
Oh,
that?
it's gonna.
That straight line on those buildings is dancing left and right and waving around like it's made out of jelly. I rest my case.
Okay, so are you saying we're not looking at the building? We're looking
I
at
am
a hologram.
saying no.
Is it a hologram?
Did I mention hologram? Do you know what a hologram
Is
is?
it a mirage?
What's a hologram, Chris?
Is it a mirage?
What's a hologram? If you say that
Hold
I
on.
said that, what's a
Are you
hologram?
saying we're looking at a mirage?
You just said the word hologram. What's a
Do
hologram?
you understand that?
What's a
Is it
hologram,
really
Chris?
there or is it
Just
really
ha-
not there, Dean?
Do we
What's
just
a
have to
hologram,
believe that
Chris?
it's gonna look? We have the capability.
Matrix,
of,
2 seconds. I'm having a word with
Hold
Chris.
on, Matrix. Chris is on it.
So, Chris, I put it to you that you are not looking at reality. Therefore,
Wow.
to draw any conclusions from this is the only conclusions that you can support is something outside of reality, which is the mistake that you're making.
So
That
when you say
building,
we're not
all
looking
those
at
straight
reality-
lines there, wait a minute, all those straight lines there, they're not straight and they're mutating. Are you saying that
Well, why are they mutating? Why are they mutating?
because light bends, refracts, and it does some weird and
Right.
wonderful things? Yeah.
So to refract and bend, we have to be looking at the actual object, correct?
No, incorrect. Not geometry-wise, incorrect. We're looking
Not
at the light
geometry?
from.
What do
No,
you mean
not
not
geometry.
geometry?
Reality.
Hold on. We never see the geometry of a building because there's always refraction of some sort. So you're never.
Yeah, that's why I
looking at-
said reality.
Well,
we're
but you're
never,
having to
okay, but let's
contend
make clear,
that these
we're
aren't
never
really there.
looking at what we'd call reality then. We're never looking at the geometric position because even if you're looking at a tree only a few hundred yards away, it's actually raised up by about an inch or something because light is always refracted in the atmosphere because of the density gradient.
Okay, well, that's not always
and it
the
varies.
case.
So this is why Chris has got something here, in which case this is, I think, Red Pill said that on 2 occasions he could see almost all of the buildings, but normally he couldn't. And we can explain
Well,
that
look,
by
you can see
saying,
a boat down.
hold on, Chris. Hold on, Chris.
Down here.
Let me just finish.
There's a boat.
And there are unusual conditions that Red Pill
The
had
boat's
where
not
he could
there.
see more, but normally under the standard conditions, things were obscured. And
No,
that
you
could
know
only
that-
be- and they could only be
You know
accounted
there's no-
for by the curvature of the Earth.
Yeah, so wait a minute. Like, we don't have to bring curvature into it. All we need to do is say, if I can go to the same point which Red Pill said in when he was showing us this for the first time, and said sometimes I can see it, sometimes I can't. Brilliant. Do you think that represents reality as a fixed constant then? Because it really doesn't.
It represents what the atmosphere can do.
Correct.
When you're looking out over long
Correct.
distances.
Correct. Awesome. I'll give you that. Awesome. So,
Right.
given the fact that there is that much variance, should we draw any conclusions about where shit is?
Well,
Yes or no?
if that's
Yes
your
or
response,
no?
let me
You
answer,
could-
Dean.
Okay.
Let me answer. If that's your response, then we're at a stalemate.
No. Do it without
Yes.
refraction. Do it on days with little to
You
no
can't.
refraction.
It's impossible.
Little
Dean.
to no. Little
There's
to
no such
no.
thing. There's no
Like
such
this
thing.
one. I don't have the refraction here. Not much.
I've got
How
a
is that,
great
uh,
one.
How does one
geometry
even
thing?
put that into calculation?
Wait a minute. I say we go off this because this will be a stalemate in the fact that I don't accept that evidence because the building's made out of jelly if I accept that as reality. And I know that they don't make buildings out of jelly.
But
And
we know that refraction can cause that phenomenon of an actual object.
absolutely,
go
we
ahead
know
and
that it can move it. I say we listen to Bob. Bob wanted to show something now.
No, I just want,
Yeah, I
before we
can
do that,
demonstrate
I'll
this
try to say
nicely.
something just before we move to Bob. Chris, the fact that Red Pill found some unusual conditions, we know the atmosphere can do weird things like creating mirages and upside down bits and bobs.
So
We
we're
know.
okay,
Hold on, let me finish
Where's
my
the mirage?
sentence.
Where's
Let
the
me
mirage?
finish my sentence. So
Where's
we
the
know
mirage?
that you. Oh, let me finish my goddamn sentence.
The Rumpus haven't spoken.
Oh,
The
jeez.
Rumpus haven't spoken. Giving a chance to speak at least a freaking whole sentence, Chris and guys.
So we know that you can have unusual conditions in the atmosphere which cause weird and wacky things. So those conditions, we say, those are unusual. They do not represent a stable state. We do know that most of the time these buildings are obscured and that occasionally there are conditions in which you can see them. So we can draw conclusions from that in the standard conditions, we cannot see those buildings. And also I'd like to know from Bob, the wind turbine, how high it was. Also, and Red Pill was very low. We know that you get extreme refraction conditions when you're very near the ground. He was taking that from about 6 feet up, whereas I suspect that Bob, Tommy, I've got my Tommy's and my Bob confused. Tommy took his observations of wind turbines. I suspect he was quite a lot higher up.
70 feet.
70 feet, there we are. So you tend to avoid troublesome refraction. So, for instance, though, he observed some observations we saw of Mount St. Helens, again, when that guy was about 200 meters up. You don't tend to get these sorts of extreme refraction conditions. You only do it when you're near ground level. Finished.
So just to Jose, to put it to the audience for those. So first of all, let's bear in mind that this debate isn't for anyone on the panel, right? I have my mind made up. Rumpus and Dean have their minds made up. This is for people who are honestly looking on the fence for the truth and want to know, okay, what's the deal here? What's the deal there? So you have to either believe that this building is cut in half due to curvature, or it's cut in half due to refraction, or you have to believe the entirety of this building from the tree line to the water line that you don't see in this image is loomed up around the curve of the earth, or it's just on a day that has different refractive conditions and you can see the entirety of the environment. Those are your two options, and I put it to anybody who's reasonable and logical to use your own brain and come up with your own conclusion on that, I guess, because according to Dean, we can't tell which is reality.
All right, then I'm going to lay a little bit of reality on you and
thank you, Bob.
show you the bottom line. Do you recognize that photograph right there?
We just see your logo.
Why do you just see my logo?
Yeah, I don't see your screen.
Well,
you're not screen sharing, Bob.
I was.
Well, you're not now.
Come on, this guy who can't screen share is going to school us.
Chris, just
yeah. As a matter of fact, I am, Chris. I'm going to school you big time right now. Now, do you see that?
Yeah.
All right. You guys recognize that photograph, or do I have to go through 15 minutes of explaining what it is?
I got it.
All right. Watch and learn. Do you see the two peaks that are marked 1 and 2?
See.
Bueno. Care to look at the mountain now?
That's missing a big part.
Watch. You see the mountain lines up perfectly?
Mind blown.
Do you
Something's
see?
going on there.
Tell me where the horizon is in this picture right here. Chris, Matrix.
Chris
Show
is
me
just
where
getting wrecked today.
Where's the horizon, Chief?
You tell me where the horizon is.
No, I want you to do your own research.
This isn't my image. This isn't my analysis.
Do you know what it is?
About it.
Do you know what this image is?
No idea.
Chris, you just used Red Pill's image. So what?
All right. So
Yeah, I've looked
basically,
at this is a simple video from 14 miles. This is like what, over 100 miles?
this is 197 kilometers.
Excellent.
And do you see the red line there? That's the line of sight from Malibu to Mount San Jacinto. Now, I want you to look right up here by where that red line intersects the black horizon.
So I have a question for you, Bob.
Not answering questions yet. I'm not done presenting. Do you see that little cross red mark at the red line just to the right of it, right about where the horizon is? I want a yes or a no. Do you see it?
It's a bit small.
Yeah, it's very small. Do you want me to see if I can make this a little larger for you? Would that help? Okay, so I'm gonna. It's not working. Sorry about that.
It's good enough.
All right, but in any event, do you see that red cross line right there? You see how it comes right in where the horizon is? Yes or no, Chris? Do you see that cross line? I will show it again until you answer. I'm going to keep rubbing this right down your throat until you admit it. I want you to tell me whether or not you see that cross line. Right there. You see it?
Bring the popcorn.
Right there. You see it? So, Chris, you're basically shut up now. Okay? That is the predicted.
I have a question. You let me know when you're done.
Yep. That is the predicted visible. That's the demarcation between visible and hidden by curve based on the advanced curve calculator. And as you can see, it matches the horizon perfectly. I'm going to leave that up, and then I'm going to allow you to ask your silly question.
So how did you take into account atmospheric refraction in this analysis?
Standard atmospheric refraction.
So there's no such thing as standard atmospheric refraction. In fact, if you look at Metabunk, there's a new note that Mick West had to add because he was getting wrecked, where it says, "Note, not accurate for observations over water very close to the horizon."
That's not very close
because
to the
the
horizon.
atmosphere is ever moving constantly.
It's like a script we're using.
That's fine. That's fine. All right. You could say.
So I'll ask again. How did you take into account atmospheric refraction in this analysis?
And
How much would that be?
I'll answer the exact same amount again. I'll answer the same answer again. I took in standard atmospheric refraction and look at the prediction it made.
Bob, what's the observer height on this observation?
And what is your altitude? What is your altitude?
54 meters.
Right, so he's above the ground level, so that means he doesn't.
Exactly.
He can use standard refraction when you're that height. You
Let's
do
just
not have to
enjoy
worry.
this a little bit more.
No. It doesn't. It says over water. Is the observation over water?
Yes, it's over the
Okay, so
Pacific
then you
Ocean
can't
at
take standard-
54 meters.
Then you can't
Keep
take.
dancing. Keep dancing, Chris.
I'm just reading what Mick West had to come out and write. I'm sorry.
Yeah, I know, and I'm just sitting here for my own personal amusement, enjoying you dance, and I'm eating popcorn while I'm waiting for my daughter's graduation.
I'm not. I mean, I'm only reading what Mick West.
And I'm presenting an image to you in front of you. Now
Mick
you
West
need to
isn't
tell
here
me.
right now.
Okay,
So
Chris.
how did you account for non-standard refraction then?
He's not having to because he's
I don't have to.
because he's at this height. You
Is it over
tend to
water?
hold on. At this height of 54 meters, you tend to just get the standard refraction. But also, Chris, you can't
Well, that's
ignore
a-
the fact
that's a
there are a
baseline.
vast number of observations like this which are completely compatible with the calculations of the Earth Curve calculator.
So what is
That's
100?
ridiculous.
So what's 196 kilometers worth of refractive index due to a mountain?
Not that much.
It's
not that much. And
it's
it
included
actually,
in the Earth curve calculation.
here's the bottom line, Chris. I made the prediction, and look how it fit reality. So
Can you
the
prove
bottom
that
line
claim
is,
that 196 kilometers of refractive index won't do much?
It'll do what the Earth curve calculator says it does. It's
I
quite
predicted
simple.
it based on the curve calculator. And Chris, you need to shut up and learn now. I did it with standard refraction, and my answer was accurate within a few meters. The bottom line is,
so it was incorrect.
The proof is in the pudding.
So it was
matches reality.
The proof is in the popcorn.
If you mean
Chris, the observations match what the
Guys, I
Earth
gotta
curve
go,
calculator says. Chris, do you not understand this? The observations match what the Earth curve calculator says.
Well, the Earth curve calculator says that you can't use standard refraction anymore.
It doesn't say that.
It doesn't say that at all.
And I will
Chris,
and I will confirm that when you make observations from a reasonable height, you do not have these problems with extreme refraction.
So reasonable height,
Chris,
and 54 meters is a very reasonable height.
Chris, do I have your attention, Chris?
Well, you haven't answered any of my questions.
This is why flat Earth is a movement.
Bob, is there
It is
compression
not
in that?
science. Is it
Hey, Red
6,000?
Pill, bitch made.
Hey, what's up, Tommy boy?
Yeah, you see, the thing is, this is why flat Earth is a movement rather than.
Bob, answer his question.
Hey, Bob, is there compression
or
in that
anything
image?
else. No.
Maybe
I'm
you
sure
can
there
zoom
is a
in so
small amount.
Can you zoom in so we can take a closer look? Because I don't know if you knew this, Bob, but the reality of compression throws a big monkey wrench into all blink tests.
All right, so you want to sit down and say that over 6,000 feet of that mountain is compressed, but the top 4,000 feet is not compressed.
I want to say that Mick West said compression is real, and when things compress, you can't necessarily just blink test comparison.
Okay, but how much compression?
There is no compression. That's what Bob is offering.
And how do you explain the fact that this matches the curve?
Hang on, I was gonna ask it. Well, that's why I wanted Bob to zoom in so we can see if there's compression. I mean, you have to look for reality. You have to consider the variables, guys. You can't just, No.
So Red Pill, just really quickly, there's a bigger issue. You're arguing about compression, which we normally find as a small band, especially in your photos lower down that are very close to the waterline. But in this, in what Bob's showing, there's a bigger problem here. The volume that would represent this mountain in an optics view has transformed downwards. So we can say, well, compression could be occurring. It might be turning 100 meters into one, but that doesn't explain the sheer magnitude of the fact that that mountain wouldn't even be in the photograph there. It would be well above and beyond it if the Earth was flat.
Here's the bottom line.
I'm gonna get my footage real quick. You guys can talk. It's gonna take a second. Get my footage.
Here's the bottom line. This is absolute proof of curvature, and any attempt to try and allude that this is compression or atmospheric lensing or perspective or any nonsense is disingenuous. And it's just sitting down following a narrative. I'm not desperate for anything.
We need a mirror up in the clouds to do that one.
I just handed you your asses.
You guys are so desperate for proof of curvature. It's funny.
You're desperate to prove the flat Earth, but
you're stuttering, Tommy.
That's a good point. RPP. This isn't proof of curvature. It's proof of a phenomenon where the mountain possibly appears lower.
Yeah, it's embarrassing. It's embarrassing. It's so anti-science. So embarrassing. It's so anti-science, and these guys are going to look back in a few years and be embarrassed by what they stand for.
You need to.
Why don't you?
Okay, all right. Red Pill. I think you need to open up some more tabs. Your IQ is kind of.
Anyway, so yeah, I'm just looking at. I know.
Well, they don't want to.
Hey, Red Pill, here's the problem that I have with you, Red Pill, is that you apparently are a relatively smart guy, and
thank you, Bob. I agree.
And you think that by being a Poe, you're just getting clicks here.
What kind of conspiracy theory do you have now, Bob?
I don't have any conspiracy theory.
That I'm a Poe, so what? Am I scheming to deceive people? What a conspiracy theory!
I think what you're doing is trying to.
Dude. Hey,
No,
you're
I just
paranoid,
think you're
Bob.
trying to get. I think you're just trying to
You're
get
a
clicks.
paranoid guy.
Yeah, Bob, take a look at my last video. It's about him.
Conspiracy theory.
This bitch made.
Yeah, I know. Yeah,
Oh,
Brady
what's the
Beaver's
name of your
got them.
channel there, Tommy? I'm gonna go.
It's my name, Tommy Dunwall.
All right, almost got the
gonna
footage
go
up
subscribe
here.
real
I'm gonna
fast.
pull this link up here.
I had to
But
buy a whole.
hey, Red, can you tell me where the 6,000 feet of
Let
that
me go
missing
ahead
mountain
and
is?
share my screen here for
That
you
was
guys.
5 people talking at the same time.
Hey, Red, can you tell me where the 6,000 missing feet of that mountain is?
That's you're literally retarded, Bob.
No. Okay, there's
so
the
cute.
answer.
Okay, so the
there's
abusive
really not
ad
much to
hominem.
say. It's
That's the
complete
best answer he
idiocy.
has.
There's not much to say. There's not much to
the
say
abusive
to a bunch
ad
of
hominem
There's really
defense
not
is
much
the
to
only thing
say
you
to a
can
bunch
do.
of cult members.
Yeah,
There's
there's a
not
little
much
bit of
to say.
trolling. You
Red
know
Pill.
what? Hey guys, hold on really quick. There's a little bit of trolling going on. I'm enjoying it. It's cool. I mean, try not to go hard on personal attacks and all this shit. It's fun for now, and we are able to get the word across. Try not to overtalk each other too much, please.
All right. Well,
I'm chilling. I don't
Chris,
mind
Red
it.
Pill, keep it
I
civil.
don't
This is done.
take it. I don't mind it.
This is done, so I really don't need to present anymore here. I think everybody's seen it, and
Thank you, Bob.
basically that's that.
Yes, the cult members will agree with you.
Yeah.
So that's so this is due to what's called refractive sinking. Let me read you the
Yeah, they think science is funny for some reason. It's
Yeah, let me read
weird.
you the definition. Let me read the definition. In sinking, stationary objects that are normally seen above the horizon appear to be lowered, or may even disappear below the horizon. There you go.
Yeah, but that normally happen. That tends to compress things as well, and we're seeing things that are not
There is
compressed.
Well, go right ahead.
Pure.
Go right
There is
ahead and show me how
compression.
that's taking 6,000 feet of a 10,832 foot mountain.
There is compression. There was an analysis video done, which I can't find because YouTube
You're
hides
right.
all the good flat Earth videos. Where
Chris,
Yeah.
it never compresses
Now
by
we're
that.
talking about
It never
conspiracy.
sinks by that amount. We do. What you're suggesting is that mountain that Bob was showing us was perfectly not perfectly correct in aspect ratio, and suddenly when it hits the horizon, presumably you're suggesting the missing X thousand feet are suddenly compressed into one pixel. There's no optical or physical way of accounting for that. It's obscured by the curvature of the Earth. And it matches.
Hey, can you guys see my screen?
And that compression precisely matches the curve calculator based on the Earth curve of the Earth.
Yeah, that's circular reasoning, Bob.
Yeah, all it means is they hijack refraction from
Yeah,
their
that's
Oh
exactly.
my
That's all
God.
that means.
Is
It's
that the
just
video,
circular
Red Pill?
reasoning.
I'm presenting
Hijacking
you.
refraction.
Yeah, I have it on screen now. I mean, look, my point is, I mean, you can see that there's a vertical compression taking place.
Okay, have you measured out the
The
pixels
balcony
between
buildings
those?
near the top are a certain width, but as you get closer down to the horizon, and artists and designers, they know the horizon as a vanishing line. That's what they call it.
No, they
But
don't.
at the balcony
No,
building,
that's wrong.
Absolutely
Red,
wrong.
would you be kind enough to put that video or that screenshot back up again? I want
Pretty
to
sure
point
Dean would have
out
something
and
to say
school
about
you
that
a little
comment.
bit.
No, yeah, I want to see the video playing.
What does Dean deny that artists have a term called vanishing lines?
No, he didn't
No,
deny that. He said the
Okay,
horizon.
so
no, wait a
who's
minute, wait a minute.
Who's the
didn't
fucking
Let me
necessarily
answer.
match.
Who's the fucking idiot who just said Dean would deny that?
No, let me
Who's
just
the
let me just
smarty
say
pants who
something.
just
Wait a
said
minute.
that?
Stop.
Oh, Red
So
Pill. Good trigger, my boy.
That one right there.
What a dumbass cult.
So what I'm
Oh, he's
saying,
healthy.
you just made the assertion that the horizon is the point of which artists call the vanishing line, and that's complete and utter bullshit.
No, I didn't say that, Dean. You're
well,
just
okay,
not
we'll have a
listening.
look. Wait a
What
minute.
I'm saying is that it's similar.
Back
What I'm
into this
saying is
photograph
that
right here. There's a key thing right on this photograph. If you'll bring it back up, please.
Who's Bob talking to?
I'm talking to whoever's putting that condo up.
Yeah, that's me, dude. It's right here.
I would really appreciate it if you put it back. Yeah, perfect. All right. Where'd it go?
Click on his icon if you want to see it.
All right, right here. You see that? Now, if you do a pixel count, you see on the right side here, you have a series of balconies, correct? If
Yeah,
you
it's
do
my
a-
footage. I know, bro.
Great. Did you do a pixel count on the black spaces between those floors?
Pencil count? No, I did. I used my eyeballs to see that the balconies near the quote horizon are thinner than the ones up top.
Because your eyeballs are far more accurate than actually counting pistols. Okay, I understand.
Okay, so what's the point here, Bobby?
The point is, look at these top floors. You see how the distance between the floors is about the same until you get down to.
Bob, are you retarded? That's why I presented this, man. Get to your point, man.
I am getting to my point. Why don't you shut the fuck up?
I mean, I've literally got videos from like 6 months ago talking about the compression, dude. You're not enlightening me here, man.
Okay. Now you're looking at the balcony about a quarter of the way up, and then you see the compression just at the bottom.
Yeah, you can fit like 4 balconies in the span of
No,
one.
you
up
can't.
top.
We've
It's
done
really
this.
incredible.
can you?
Really
Yeah, can you confirm
fit,
that?
Red Pill, you cannot fit the missing
All right.
floors into
Wait,
the
wait, wait,
space.
I never
at the
said.
Am
I
I
never
going
said
to
missing
be allowed
floors.
to finish here?
I never said missing floors. I said the ones that are visible right above the quote horizon.
There are missing
are
floors, aren't there,
squat.
Red Pill?
I never said
All
anything
right.
about
Red
missing
Pill,
or not.
are there not
May I
missing floors we
finish?
cannot see?
Okay,
Or
okay.
is
And
everybody
Rumpus,
just gonna
Rumpus,
talk
you
over?
saw my footage of the exact same building
All right,
where
I'm
you
done.
can see the entire building. So what's your point, Rumpus?
The point is there are missing floors that are below
Rumpus
horizon.
always has to butt in and Rumpus when
Now,
I'm
hold
showing
on,
this
hold.
footage.
Let's get this right.
There's
There are
something
missing-
about this footage
there
that
are
scares the
missing
shit out of
floors
Glovers. I don't know what it is though.
you cannot account for that are below the horizon.
Rumpus,
You
when did
cannot
I
account
say
for them
anything about
by
that?
compression, can you?
Rumpus, when did I say anything about the missing floors?
I'm talking about the missing floors. There are missing
But
floors,
I'm not
aren't there?
talking about it. So what's
Well,
your
I
point?
am. There are
Well, who
missing
cares?
floors, and
Who
you
cares,
cannot
Rumpus?
account for them by compression.
Here's footage from a different date, and you
No,
can
hold on,
see
hold on. We're dealing with
everything.
that picture.
can see
You
everything,
cannot
Rumpus.
account. You
Look, you can
cannot
see everything
account
now.
for the
All
missing
right, you're just
floors
talking over
missing.
each other.
by
And then the next
compression,
day,
can
it's
you?
not missing. Oh, it's so
No,
amazing.
on the picture you just had,
Okay.
you had missing floors that you cannot account for by the compression, which we can see. We can see this compression,
But wait
but
a
it's
minute,
not
Rumpus.
sufficient to account for
Rumpus,
the
when did
missing
I ever say
floors.
that? When did I ever say
Well,
it?
I'm saying it.
Well,
I'm
I don't care
saying
because I didn't
you
say it. So
cannot
what's your point?
account
Bill,
for
is
the
your
missing
assertion?
Yeah,
floors
let's let Bobby
through
You guys are just such
compression.
cult members, man.
You
Red
cannot
Pill,
account
are you
for the
asserting?
missing
religious
floors
cult
through
members, dude.
compression, can you? I know you
Oh,
want to
so
overtalk me and
stupid.
dodge the. You just try and deflect here, Red Pill.
No,
You're trying to
you're
deflect.
just not even
You're
making
trying
a
to
point,
dodge.
Rumpus.
You're trying to dodge the
Just really
issue
quickly,
that
Rumpus.
there are
Rumpus
missing
is so
floors that you
stupid.
cannot account for by compression.
Rumpus, you're so
Yeah.
dumb,
Why are you
dude.
deflecting, Red Pill? Don't
Rumpus,
you like
you've said
this
it
fact?
12 times already.
Red Pill,
Now,
don't you like this fact?
Let Bob
Answer
get
the
his point
point.
out, please.
Answer the point, Red Pill.
What
Stop
you need to
dodging.
answer, Rumpus, is what you wouldn't answer the last time I spoke to
I'm
you.
perfectly happy to answer any question you ask me. You answer mine. There are missing floors that you cannot account for by the
Five,
compression that
Rumpus,
we
there are
cannot.
five.
Okay, so there are 5 floors
Rumpus.
that are missing that you cannot account for. And
Rumpus.
even with the compression that we can see,
Rumpus.
you cannot
Rumpus,
account for.
Rumpus,
Okay, let me
shut
start.
up.
Let me
God,
start
not
by
He
Scotty.
won't answer the goddamn question.
Wait. I'm going to go ahead and give you an answer to your malformed question.
So
Here I
stop
go.
dodging it and answer the question.
No one ever dodged anything. Okay, so you see how obviously anybody with eyeballs, you don't need to count
Yeah,
pixels like
compression,
Bob the
we know that.
Fallacy
We've
guy.
done that. We accept that.
Are you going to let me answer, Rumpus?
But you
This
can
is
just
what you did last
I
time. You
included
did
this
the
in my
same
question.
shit last
I
time. You wouldn't let
included
me
that
answer the
point in
question.
my question. You're just repeating
You
my question.
asked the question so you can impress the idiot atheists in the
And I
audience.
mentioned
It
there was
sounds like you got me, but then you don't let me answer the
I
question.
mentioned there was compression, so you're just repeating what I said.
I'm going to answer your question. So as you can see, the balconies near the quote horizon line are compressed, and you can fit. I mean, by the time it's the bottom 3 floors, it looks like you can fit about 3 or 4 of these balconies will fit in the span of the balcony up
Are you
top.
claiming you can fit the 5 missing floors in the space between the last
But
visible floor that we can see in the
you
horizon?
let me see. The thing is, Rump, is that science
Oh.
can be complex, and we have to give thorough answers. And you
Yeah,
want stupid
stop
stuff. So
deflecting.
you gotta let me consider the variables at play here. So let me just answer the question. So as you can see, just when you get to the bottom, I mean, we're talking about 4 floors. We're talking about, look, I mean, there's 2 balconies squished so tight.
Right.
That you have to wonder, because it really does look like an
So you're
exponential.
claiming the missing floors are in between the last visible floor and the horizon.
No, Rumpus.
As I was saying before I was very rudely interrupted.
Are you claiming a fight?
It's a vertical. It's like an exponential compression. If you take a look at it, it's like an exponential compression. So you have a certain width near the top, and then it gets a little thinner and a little thinner and a little, and then it starts getting even thinner, even faster.
All right, can I have a second?
He doesn't let me finish. He just doesn't.
Red Pill. All you're doing is dramatizing an explanation.
Dean, you are
we
the
accept
damage
this
control
compression,
person
Red
for the
Pill.
globe.
We accept that. We've said so from the start.
Rumpus
Red,
never
are
lets
you
someone
saying
finish
that the
sentence.
missing
claiming
six
there
You
are
want to
five
simplify
people
science.
compressed into
You
one
want Rumpus.
pixel.
You want to simplify
Rumpus,
science. You want to simplify science so that people don't get thorough answers for things. That's just disingenuous, Rumpus.
Okay, now, Red, are you saying that the missing 6,000 feet of San Jacinto is compressed? Like,
Oh, hang on a
bottom
second.
floor
You
of
are
that
wait. You're
condo?
jumping to the other one now. Okay, that's fine, Bob. Let's go to yours real quick. So, Bob, I mean, I asked
Are
you to
you
zoom in on the
saying,
picture.
please, Red, let me finish. Are you saying that the missing 6,000 feet of San Jacinto is compressed as the bottom 2 or 3 floors of that condo are compressed?
Well, you
I
didn't
have an
even
answer
confirm.
to the
You didn't even. First of all, you didn't even
Jacinto.
confirm if there was compression. So that's why I asked you to pull your picture up and let's zoom in and take a look at it.
Wait, so now you're questioning compression?
You are retarded, Bob. If you can pull the picture up, Bob, that'd be great, so we can look at it.
I can pull up an analysis that JT Tolan Media did, where that shows compression 100%.
Yeah, and that's all I want to know. I want to know if there's compression. We have to think about science.
Media can't even identify.
Guys, we have to think about science. There's a lot of
RPP,
variables
look at
in
my
science.
screen. Look at my screen, RPP.
Yeah,
Or my icon.
All right.
Yeah, that's that Jay Tolan Media crap.
I got it. Thank you very much, Chris Berry. Really appreciate it.
There you go.
So this is the compression analysis that he did that shows.
Oh wow, that's really awesome, man.
That
Cool.
shows so from this distance from here to here, from A to B, it's 300 feet, and then from the same distance, C to D is 600, and then the lower you get, it you know, what am I trying to say?
Yeah, and this reminds me of the refraction Mick West said.
Misidentified.
Now here's the
compression. I remember Mick West.
He misidentified the features in that photograph.
I love it. Yeah, compression.
All right.
Absolute idiot.
Okay, Chris, this is your photograph, correct? This is
No, it's not mine.
Is this the one you are presenting?
Which one?
The photograph on screen.
It's not mine.
Are you presenting this photograph? It's a simple
I am presenting it, Bob. Yes.
All right. Do you see the yellow elevation scale there?
Yes.
All right. Is that yellow elevation scale correct?
What do you mean? Is it correct in terms of what?
Does it give actual elevations? So, for example, if I read off one of those elevations on the mountain, is that the actual elevation of that point on the mountain?
Based on the yellow scale?
Yes.
No, because it's
correct.
Because the mountain's compressed.
The mountain's compressed.
It's called science. Mick West talked about compression.
Okay. All right. So you're going to say the bottom.
You guys can't deny science.
Well, look, he compared.
What is
Rumpus keeps saying he got the mountain drawing. He's denying it right now.
You can see. What is the lowest point on that mountain you can see?
Well, so right here he's got
F,
and F is way over here in his comparison shot, way down here.
Boom.
Is it? So you're saying F is that right there, that one little knob on the left side.
Well, that's what he's saying, but yes.
Are you saying that?
A, B, C, D, E, F.
Yeah, I know.
Go back.
We already know that.
A, B, C, D, E, F.
Okay. Are you saying that that F, that knob on the left side of the mountain, is visible?
Well, whatever this F is visible, yes.
No. Are you saying that that F is that knob on the mountain?
Yes.
Okay, so you are. All right. I want you to show me that knob on this screenshot right here.
Well, Bob, is there compression or not in yours?
Probably a tiny amount.
Did you even consider it? I mean, why would you deny basic variables?
I don't need to, because what I did was I did a direct comparison of the photographs. Now there it is.
Wait,
he overlaid them, Red Pill.
Wait, you overlaid.
So how did you get that? I have a question.
This is for Chris.
I have a question for Bob.
No, Chris. Where is
How
that
did you do your overlay mountain? Did you zoom in using Google Earth?
Yeah, he used Google Earth with probably no atmospheric variables and couldn't compress it. These people are so fucking stupid.
They match up. Doesn't matter.
No, they're lying cunts. That's what it is.
Yeah, you don't like it, do you? The
Was
evidence,
it Zoom?
it matches, Red Pill. It matches.
Please, Chris, I want you to show me that knob that was on the left in the J. Tolan identified as E. Show me that in this photograph.
E or F?
F.
Red Pill, compress this one. Compress this
Tommy,
one, please.
Tommy, stop interrupting, you idiot.
Tommy, stop changing the subject. You're really
yeah, he's so desperate.
I'm
He's
trying
so
to have a
desperate.
conversation with Chris here.
Let Bob go, damn it.
Now, Chris, would you please show me where that knob is on this photograph?
Which photograph?
The one that's on my screen right now.
The one that's
We
on.
can't see anything, Bob.
You're not sharing, Bob.
You're not sharing, Bob.
I was a minute ago.
Well,
you're not now.
Computer, dude. What the fuck?
Let's try it again.
I thought you were referring to what Chris was sharing. It turns
Yeah,
out
me too.
Oh,
No. Right here. There's the photograph directly superimposed on J. Tolan Media One's photograph. Would you please show me? Would you please show me that knob on the left, Chris?
What did you do to get that photo?
Would you please show me the knob that you were referring to as F on the photograph?
Bob, it'd be very helpful if you just shared the window. You're showing your desktop. Bob, you're showing your desktop. If you just shared the window, then we could see that a
2,000
bit
years
clearer.
and no proof of a sphere. Oh my god.
No, it was fine.
Now
though.
who's denying science, dumbass?
Bob,
Shut up,
what
science
did you do to
denier.
get the comparison 3D?
This guy's drinking alcohol at 10 a.m.
How did you get that?
All right, I don't really have
It's
much more time for you here.
called the East Coast, you
There
shit
you
lord.
are. There you are. Now,
Still too early for alcohol.
Chris,
How did you get your blue test photo, Bob?
look, I'm not even going to bother continuing if people keep
Is
interrupting.
it a zoomed in shot?
Yeah, this is the zoomed in shot that matches.
Why is it zoomed in?
Because that's what you have on J. Tolan's shot right
It
there.
is?
Yeah,
It's
right
zoomed
there.
in?
Yeah, right
How
there.
much is yours zoomed in?
Exactly the same as Tolan's. You see, here's Tolan's shot.
Exactly
and
the same. It doesn't look the same at all.
It looks exactly the same. Right
No,
there.
it doesn't.
Can we just establish one thing? That he's overlaying an image from Google Earth with no atmospheric considerations. So
And
dishonest.
what's the distance?
So
Bob? What's the
dishonest.
distance between
There's
the Google Earth
there.
observer?
Red Pill, if you understood about refraction, you'd realize that
Only
was a
low
valley.
IQ atheists fall for this
You
shit.
don't understand, Red Pill, because
All right.
the shape is not
Let me ask
changed.
Bob a
So
question
you
about
can
this.
overlay the images
Rumpus.
even at different
Oh,
heights
Rumpus.
because
No, dude.
refraction does not check. When you've got standard
All right, I'll go
refraction,
ahead and
it
I'll
does
stop-
not
I'll stop
change the
sharing and let
aspect
Rumpus
ratio
talk.
of the image. So it's a perfectly
Rumpus.
valid
I'll go ahead
thing to do.
I'll stop.
All the
Let
standard refraction
Don't,
does,
don't,
Red
Bob.
Pill, is
Bob,
change the position of
Rumpus.
something. It doesn't change the aspect ratio. So it's
Rumpus
perfectly
is
valid
ruining the
to
hangout.
overlay it. You don't understand. You're a moron.
All right, gentlemen. I've got my daughter's
Bob,
going to graduate,
one more
so I'm going to
question,
get
Bob.
going.
One more quick question,
Thank you,
Bob.
Bob.
Thank you, Bob. You got
Do what you gotta
rumpus.
do, man.
You got the
Quick-
shit out of
Rage
your rumpus today, bro.
Now, just a quick question.
Rage quit.
How far was the observer to the mountain in the Google Earth 3D image? Okay, he doesn't answer the question.
What,
So
he was dealing with his daughter. Don't be a twat.
So dishonest, man.
he's dishonest. Yeah, that's it.
It's
Yeah, he
just-
went off his
Look,
daughter.
there's
That
only
makes
two
him
options. You're
dishonest.
either
Oh, shut
retarded
up,
or
you
you're
twat.
dishonest. There's only two options, man. I mean, at this
God,
point.
yeah, he's dishonest. Yeah, he didn't have to go into his daughter. Yeah, he just messed
Position
up.
and heal thyself. you
Oh.
fucking idiot.
Incredible. Just
Red
incredible.
Pill, can I ask you a question?
You morons.
Just incredible.
Red Pill, can I ask
You're
you
a
a question?
moron, yeah.
Anyway, so yeah, the compression is real, and I don't know why you guys.
Yes,
just
no
pretend
one's
it doesn't
disputing
exist.
the compression, but do you don't understand the compression that you witnessed in your images
Yeah,
was
you
due to the
straw
fact.
man.
Hold on.
Straw
The
man.
compression that you witnessed was due to the fact you were very low to the
Straw
ground. Your
man
elevation.
obfuscation.
Hold on. You don't know. You don't like this fact.
That's
You
not
I'd rather
why.
talk to
you
Tommy, 'cause you're
only
just gonna
get
rump
that
it.
sort of
Tommy had a
compression.
question. I'd rather
You
talk to Tommy.
only
You're
get
just gonna
that
rump
sort
it.
of compression.
You're just
when
gonna
you're,
rumpus,
you
so
only
I'd
get
rather
that
answer
sort
Tom.
of compression
Tommy,
when
look, Tommy
you
had something to
only
say.
get that sort of compression.
No, you
you
don't.
only
No, you
get
don't.
that
No, you
sort
don't.
of
No, you
compression
don't. No, you
when
don't.
you have a low elevation height.
Well,
No,
In
that's
his
wrong.
example,
representing himself. That's
in
amazing.
his examples, he was not.
I just muted this one for a second because he's getting like really bad. The rumpus is rumpusing the shit out of the hangout. I'm gonna let it run. They're not hitting me what I say, but you guys are hitting me on YouTube, so I'm gonna unmute it, and you guys know. I know. Yeah, it's alright. Alright, guys, carry on.
compressed at all?
Sorry?
Is the San Jacinto Mountain, does it have any compression at all?
Well, because the observer, as I understand it, was at 54 meters, you don't tend to get very much compression when you go
Okay,
up
that's
to that
not the
height.
question. Does
But
the
you still
mountain
get
have
looming.
compression?
You still get looming, but that means that the aspect ratio is preserved. You just get you get it translated upwards. You don't get compression when you have a higher
Trumpus.
observer height. It's quite
Trumpus,
simple.
I had a question I didn't get to ask you. You know, there's so many variables, right? There's compression, there's super looming and stuff. You know, for hundreds of years, the textbook said that Aristotle's ancient observations were conclusive, slam dunk proof we live on a sphere. Did he know about compression, super looming?
He was
Aristotle
aware of some.
calculated a sphere. He didn't prove it. He calculated it. He knew it was a sphere.
No,
He just
we're talking about
wanted to see the radius.
we're talking about the Aristotle ships disappearing bottom up. That's
Yes,
what
but
we're
he
talking
knew. Yeah, he may not have accounted for refraction, but what he could do.
So how did he know
Hold
he was
on,
seeing,
I'm trying to answer your
bottom-up
question.
disappearance?
Okay, you've asked the question. I'm trying to answer it. He
Oh, okay.
may not have been
10
able to
minutes
account
more.
for all the refraction effect, but what you can do is still come to the qualitative judgment that the ships are descending below. So you do
Right.
not need to understand refraction, because the refraction effect for standard refraction is about 20% of the object. It gets loomed
So
up
in
by
other
about
words,
20%.
it was inconclusive garbage.
Hold on. So it gets loomed up by 20%. So in other words, it still doesn't change the fact that things disappear from the bottom up, and that
Why can't you guys measure curvature directly?
by the curvature of the Earth.
Why do you guys always? Why do you
Wait a
guys?
minute.
We
why
have.
is all- why are all your proofs? Why are
Wait a
all
minute.
your
Red
proofs?
Pill.
All of your proofs are like
But
far
they're
away
there.
and
We
ridiculous.
understand exactly what's
It's weird.
going on.
No, wait a minute. Red Pill, when you say why haven't we measured curvature, the thing is it was measured a long time ago, and when you get to a point
No,
where
I
you
said directly.
wait a minute, listen.
I said
listen,
measured directly.
Listen.
Keyword.
when
Keyword.
you
Directly.
Okay.
Don't
So
strawman
we can so directly, but when
Because
you can
here, let me
to
just
figure out
let me just qualify.
when you can figure out the shape of something by flying away from it and looking back.
This is what you always do. You appeal to low quality evidence. Things we can't verify or repeat for ourselves.
Unicorns were proved a long time ago, mate.
They're repeated and verified, Red Pill.
No.
We've
Who
got
measured it?
Who measured it?
Hey, Red Pill.
Get in a rocket ship. We
I had a
can't
question
get in
for
a
you.
rocket ship.
Yeah,
We
you
would have to go at least 128,000 feet, according to Neil deGrasse Tyson, to even see any curvature.
That's incorrect.
Oh,
You
wait,
can
so you're
actually-
relying on
But
Neil
that's what
deGrasse
Neil
Tyson's
deGrasse
authority?
Tyson says. He supersedes all your guys' credentials. put
NGT also
together.
says the Earth isn't flat, so
But
there
he
you go. Argument
contradicts what
done.
you guys are
What did I
saying
say?
about where you
Shut
can
the
see
fuck up. You're
curvature.
done.
He contradicts what you guys are saying about where you can see
There's zero
curvature.
curve at 120,000 feet.
So how
Why would
high
that?
do you have
Because
to be?
everybody's
why
talking
would-
over each other. I want to talk too. Thank you
I know,
everybody
Reg,
for
just
checking
go.
in. I got like 10 minutes before I do my roundups. Everybody's going to have a chance to speak your final thoughts. So we got 10 minutes to go all in. Scotty Storm, welcome. I want to finish you with a boom. So all welcome to talk, different subjects, random. And now for Español, please press number 2. Gracias todo el mundo por presentarse y por venir al show de YouTube. Todo el mundo está bienvenido. So,
Stay away
estoy
from the
feliz, emocionado
The frogs are making me
y
crazy.
excitante para estar aquí con ustedes. Así que
Muchísimas gracias.
metan mano.
Red Pill, you can see curvature on the Earth by taking a photograph. What he meant was that you visually, with the human eye, but with a camera. I mean, Rory's demonstrated this.
No. Neil deGrasse Tyson. Neil deGrasse Tyson was talking about.
If you were
Oh,
to
he
take a
never shuts
photograph
up.
of
He
the
just never
horizon
shuts up.
from about 700 feet up, and you took a high quality picture, you personally would be able to see the curvature
How?
left and right. You could
How?
do
This is the difference, Red Pill.
Oh, let me guess.
Red Pill.
You have
could
let me
do
guess.
this.
You have to Photoshop it, right?
No, you take a picture.
You have to
guys.
compress it. You have to
Oh, you
compress
don't
the
like
image
black
from
Red
left
Pill.
to right. You have
Yes,
to
because we live in a
Photoshop
freaking
it.
big
You have to
globe.
Photoshop it. Oh my God, it is
Hey,
Photoshop.
NGT.
Because
Hey,
it has to be. It is
Hey.
Photoshop because it has to be. Oh my God,
Hey,
you guys are
NG.
pathetic.
Red Pill. Wait a minute,
NGT.
Red Pill. Just really quickly, Red Pill. You don't have to use
Oh,
Photoshop. You can
God.
actually print it out and do it with a piece of glass as well. Photoshop has got
Yes.
fuck all to do with
You
it.
guys-
All
you
you're
guys-
actually doing is you're compressing it. Correct, but you're compressing it because of because of something that we have in reality, whereby if there is a small detail, you can accentuate it by putting it in a smaller space. This is called logic in reality.
Where you guys put it into Photoshop. You guys put it into Photoshop and
no, Red Pill.
No,
Hey,
Jesus, you're a
turn.
kid.
Photoshop because it has to be. I understand, guys. It's tough.
Retard.
Do you not
This is my
understand?
turn.
Hold on, Red Pill. Do you not understand? All we're trying to do is to put a horizontal line on the image. If you want to avoid Photoshop, you could. As Dean said, you could print it out and just use a ruler and get exactly the same result.
Yeah, let Tommy show this, because he's done it, and I refuse. I actually refuse to think that Red Pill philosophy is this dumb. I really do. I think this is trolling.
Yeah, I
I've
think
been quiet long enough now. Now it's my turn. So shut up, Red Pill, and I'll show you.
Great, Tommy. Well done.
So let me look. Neil
Tommy's
deGrasse Tyson said you can't see the curve from 128,000.
Stop straw manning, Red Pill, and look at what Tommy's showing.
That's what he said. That's what he said.
Red
Pill. Let Tommy show us the evidence. You had a presentation, Red Pill. Let
Red
Tommy
Pill.
have one.
Shut up and let my bitch maybe one more time.
Hurry up, Tommy. Come on, get to the point. Let's see what your dumb shit is.
What did you say about in that picture? So with the story high building, you said compression, and you said something about vanishing point. What was that vanishing point?
You want me to refute the picture on screen? Is that what you want?
No, just tell me what your vanishing point is.
So, number one, I would want to make sure, and I don't know if I can see it in this picture. There better not be a what's that called? An inferior mirage, because that can artificially lower.
No. Just define your vanishing point.
To clarify, is there an inferior mirage on that horizon? Just answer the question, dude.
It's not. I just wanted to verify. Tell me what your vanishing point is.
My second question about your picture is
Are
it
you going
just
to answer this? Still ask a question.
Hey, come on! You're presenting evidence. Let me refute it. My second question is,
just ask you. What's your vanishing point?
Am I just confused, or does it seem like the horizon is different heights on the left side of the tripod and the right side? Could you maybe clarify what's going on there?
Yeah, sure. I'm hand holding a camera with a zoom lens, and the camera was not dead level. That's it.
No, it just looks completely uneven, but that's fine. That's okay.
You have a level line in the middle. I thought it was level.
Yeah,
here's the other thing. I'd like to also point this out. That little lighthouse or tower stack, whatever that is, you can see that there's land protruding out from it. And if you look all the way to the right edge of the land, it is before the end of the water line, meaning it's not in that. Yes, exactly. So that island doesn't appear to be at the actual horizon line of water in the distance. So that will affect the inferior mirages that take place on the horizon line. So my question is, inferior mirages will make the apparent water line appear lower than it actually is. So I would like some confirmation that there is not an inferior mirage taking place out there.
It's not.
So that would be my first question, basically.
Yeah. And I asked you one question. What is your definition of vanishing point? Why can't you answer that?
I mean, if you want to deflect from your own image, that's fine.
No. I asked you, what's your definition of vanishing point?
I don't understand why you can't answer basic questions about your evidence.
He asked it first, you dumbass.
Do you know anything about the environmental conditions that day? Can you tell me temperature, water temperature?
Why can't you answer?
Do you not have any evidence from any
I
data?
just asked you, what's your definition of vanishing point? That's easy. Nothing to do with this picture.
Oh, you just presented it for no reason? That's very strange.
No,
okay.
I just want to know, what's your definition of vanishing point?
Okay. Oh, yeah, sure. I'll give you that.
Why are you deflecting all the time? Why do you answer Tommy's question? If you can't answer, just say I don't know.
It's because RPP is the Poe.
I'm going to give him the answer right now.
This is why I ran away from a one-to-one debate.
Okay, so I'm going to give you the answer now. You want it?
Yeah.
Okay. Well, in design and in artistry, the vanishing point is where the sky appears to meet the floor in the apparent dissonance caused by perspective. They call it a vanishing line because I guess you can't really draw much more into that highly compressed zone.
Yeah.
But that's what it means in artistry. And
that means that nothing can cross that vanishing point, right?
Well, I mean, I hope you understand that parallel lines never meet, right?
Yeah, sure. Explain this then.
It's a really basic concept. I hope you get it.
Yeah, then explain this one.
Very simple.
I'm 70 feet above water. Those windmills, the top of them are 1,000 feet above water. Those are below my eye level. How did that happen?
Sorry, what are you showing? Oh, hang
Sorry
on.
to interrupt, Tommy. Where are you getting this horizontal line from? How are you? How are you
Center of the lens,
Number one, we have an
Yeah, but how does he know the
inferior
lens is pointing horizontally?
I need one person to mute. I think it's Schrodinger's cat. Maybe it's like a breather. Somebody
I'm
is
gonna
like
show that again.
breathing down the microphone like all show long. It's kind of annoying. Thank you.
Ah, right. So Tommy, you've aligned this horizontally, have you?
I can show this again, please.
Ah, I see. Right.
Yeah.
I see. Uh-huh.
This is eye level. The camera's level. The water is
Right.
level. That's eye level, right? Just let me go through this, please.
Are you just going to show a bunch of images scattergun
That
style?
is still eye level. Eye level
Why are
at the
you
top of my
afraid of
screen.
my scrutiny?
That is still eye level
What are you
at the top
afraid
of my
of,
screen.
Tommy?
It doesn't matter what I
Why don't
tilt
you
the
go
camera.
back and
That's
show
still
me
eye
your
level.
observation?
I just
Great
want to
stuff.
clarify eye
Great
level.
stuff,
You're
Tommy. Great
arguing
stuff.
with a straw man. You're an idiot. Number one, there's an inferior mirage taking place.
Where?
Oh man, you must be blind, dude. Right to
Yeah,
the
it's right
left.
behind
Talking
the
about this
boat.
little
There
part?
it is. Good job.
That little part?
dumbass.
Yes.
Is that little part enough? That's it. Sure.
Well,
Hey, look
a lot
at
of
my
times when
screen.
there's an inferior mirage, you know, it could span out pretty wide. It really depends on the day and the conditions. I think it's kind of funny, you know, that you chose to take images of an observation with a giant piece of rock blocking half the horizon that's actually in the foreground and not at the horizon. No, it's very interesting. Like we want to see
I've got a
the
question.
horizon.
Yeah.
We want to see things
Wait a minute, Red Pill.
disappearing
We know
into
we-
the horizon.
You
Red
can't
Pill,
sum up. Sorry.
Red Pill, stop preaching 2 seconds, Red Pill.
See that, but you put a giant
Okay.
fucking rock in the foreground. I
Yeah,
just
you said that.
Amen.
You
Praise
said
the
that,
Lord,
Bill.
amen. I got it.
Verbal masturbation here, right?
Oh,
now,
I got
Tommy,
image fed twice in 2 days. This is great.
Tommy,
you're
do
gonna
me
need another
a favor,
location.
Tommy.
RPP's like triggered
wait,
at
wait,
5 o'clock right now.
Yeah, wait
I hear
till
you.
it's finished. All right, okay. Yeah, Tommy, I've got a question for you regarding this. So you got the
Really?
survey data from those beautifully non-singularly scaled. In other words, they're uniformly scaled based on perspective. They're not compressed or anything. All those
Oh my
blades.
God, look at that.
The blades
You put
at
a
the
giant
angle.
rock in the
Right,
way.
are you
What
ready?
an idiot.
The blades at angles are actually the same with the blades at other angles, which tell us that there's no geometric distortion. But Tommy,
Nothing.
my main question here is, could you just indicate on that image with your mouse or maybe some selection where those actual turbines should be if we were looking at a flat surface?
If there's compression.
On this
then-
image, it should be well above eye level.
If there's
Right, so
compression.
we're on about.
then-
So wait a minute. I'm not done, Red Pill. I'm talking with Tommy. So you're saying that they would be above that line. How high above that line would they be?
That's
Look
hard
at
to
the
tell.
left.
I cannot tell that.
Look at the left. Oh my God, go back to that cartoon, dude. You have a giant rock in the foreground right there. Why did you pick that spot, you idiot?
Red Pill, shut up for a second.
What an idiot.
Hey, shut up for a second. This is water.
Put a giant rock in front of what you're trying to look at.
Wait a minute. Red Pill, just so that you
Red Pill,
know, the only
this is water.
person with a rock fetish
What a
and thinks
little
this is
rat
funny
weasel.
is you.
The best you
Yeah,
got
I
is
know.
a giant rock.
What's the
Obscuring.
difference does a rock make?
What an idiot.
It's an island.
What a complete fucking
Here.
idiot.
This is
Right, okay,
Red Pill
okay.
is very triggered right now. This is like
we're missing.
self-soothing.
We're missing
Red Pill, are you on the spectrum?
You're just trying to disrupt this, Red Pill. You're antisocial. You're being antisocial, Red Pill. You're just trying to disrupt the conversation here.
Let me ask Tommy a question.
Yeah.
I have a real quick question for Rumpus, though. Really quick. Rumpus, you say, "Oh, your footage, Red Pill, was all hazy and wavy. We can't trust it."
No, Dean said that. Dean said that, not me, you idiot. Dean said that. Dean said that, not me, you idiot.
No, wait a minute. Red Pill, that was
me.
Yeah, Red Pill, that was me that said
moron.
For Tommy.
Red Pill, that was me that said that.
Put a giant rock in the foreground, blocking half the horizon.
I think Red Pill's confused with people
Yeah,
and
you're
things.
confused about reality, and you can't even remember something happened.
Let me ask Tommy a question.
Jesus Christ. Do you remember to put your trousers on, Red Pill?
This is awesome.
Red Pill.
Either that or he actually is.
Guys, hold on.
You're without your trousers, aren't you?
Let me ask Tommy a question. Rumpus,
I hear
let
you.
me
Just
ask
don't.
Tommy
Can
a
I hear
question.
you?
Incredible.
All right, click on my icons, and I'm sharing a YouTube. Tommy, I want to ask you a question.
Yeah.
Where's the horizon in this image?
That's not easy to say because that's boiling of distortions.
Wait, why is it not easy? Why can't you just tell me? Because you're asking us that in your image.
Wait a minute, Chris. You're doing the same thing. Tommy's observations. We could point and see no distortions. You're trying
That's
to find
not
flat
true.
Earth by pointing at a
What
glass.
distortions do you
at the
see
world.
here?
Wait a minute, at the world.
Dean,
when
I'm
it's
not even
upside
talking
down.
to you, Dean. Dean, I'm not
Well,
talking to you.
You're a moron.
Dean is the
I
damage.
can take a guess, just slightly above that line, because there's some mirroring going on there. But yeah, I can
Okay,
guess
slightly above.
Just a
Let's
slight,
see.
yeah, slightly above.
Let's see.
Just might.
Let's see. Hold on. Let's see.
Yeah. That's some distortion, yeah.
Is that slightly above?
But hold on, Chris.
not
Why
where
do you
that
presume?
is.
Hold on,
It's flying boats.
Chris,
It's a
why do you
flying boat.
presume that what I call the fold line has been called the fold line for hundreds of years? In other words, where you get between the infirmarage and the bottom of the horizon. You don't know that's where the horizon is. You're just assuming that where the fold line is where the genuine geometric horizon is. That is not the case, and I can show from ray tracing that that's not where the horizon is.
There's
just
the
because
horizon.
that's where the fold line is does
That
not
is-
mean
that is-
that
yes,
is
it does.
not. No, that
Yes, it
you're
does.
just presuming that because that's
It's not
where
a
the
presumption.
fold line is, that's where the geometric horizon is. It is
All
not
right.
in the same place. You've
Look.
no scientific basis for that assumption.
Let's look at
All
this
these
one.
lines are drawing. That's not where the geometric horizon is.
Okay.
Let me count that boat with a tip of
This
my
is
own.
gonna wrap up the live show on YouTube. I
Yeah.
might hit the record button when we do the roundup over here live on YouTube. I can record the after show and just upload
Yeah,
it later.
record it.
I got like a ton of
Record it.
them, but the best ones are gonna upload them soon. Everybody gonna have a chance to speak your piece, and let's get out of here. I mean, you can stay in the hangout and then talk in the after show, but please, one-on-one, when the person is giving the final thoughts, do not interrupt each other. Who wants to go first? Let's go down the list then. All right, we'll start with our Trexis. Go ahead.
Oh, this was entertaining. I mean, I can't really say much more than that, but I mean,
Thank
glad
you.
that it drive people to drinking. So
Thank you very much. Who goes next? Chris, go ahead.
I mean, look, we have explanations for all of these land-based, sea-based observations. So, for example, Rumpus has his turbines cut in half. That's simply due to refraction. And Red Pill has demonstrated that beautifully with his 12-story hotel that's cut in half. So 6 stories of a building cut in half simply due to refraction, because then on another day, we can see the entirety of the building, the tree line, and the water line all in the same image. So we know it's refraction. The boat's cut off. It's all refraction and sinking. We do know that the midpoint of the boat and or in a fold line is the top half is the real object, the bottom half is the mirrored object, so we can deduce that it is the true horizon. And as we can see in this image and video and many others, that the quote unquote horizon, you know, they present the horizon here when really in reality it's way up here.
All right, thank you very much, Chris. You gotta mute yourself, Tommy. Well, it's your turn. Schrodinger's cat. Final thoughts.
Yes, sir. Again, thanks for having me on. It was a good show. Got a little loud there at the end, but had a ton of fun. A little announcement. Tomorrow at 5 Eastern Standard Time, I'm scheduled to be debating Pete Shea on Channel Q.
Oh, God.
So we'll see how that goes. Yeah.
oh my God, why?
That's
Schrodinger,
awesome.
don't do that.
I'm going to, yeah, if that goes down, I'm going to share it on my YouTube post. So I'll create a post when that goes live. That's going to be great.
Yeah, it'll just be a ton of fun. I don't expect anything substantial to come of it.
Drink
it's
heavily
gonna be good.
beforehand.
Yeah,
Drink
it's my
heavily
day off. It's
beforehand,
my day
Schrodinger.
off tomorrow, so I'll be able to be like all in the chat, and she opens the panel, I'll jump in because it's gonna be fun stuff.
Yeah, it should be fun. And also, Red Pill Philosophy owes me money because I had to buy a whole separate computer and this separate computer is just dedicated to having tabs open.
He doesn't have money. Come on.
So funny.
I opened all the tabs. I don't use it for anything else except open tabs, and I'm so much smarter now. That's all I have, sir.
Simon Dan call
Thank you, Schrodinger's. All right, please, everybody else, Tommy, you cannot hold your laughs. You got to mute if you think you're going to interrupt. We go with Scotty. Scotty, we didn't hear you, so take your time and speak your piece, brother.
Oh, well, thanks, mate. Well, my last summary would be, Tommy, a yes or no question to somebody. Tommy, do you trust and think NASA is legit?
Liar.
Don't answer yet, Tommy.
What
Go
a fucking liar,
speak.
man.
Speak, Scotty.
Yeah, that's it.
Thank you very much. I appreciate it. All right, Dean.
Yeah, great show, Jose. And as we've seen, flat Earth proof is obviously pointing at extreme mirages, and common sense dictates that if you fill a glass full of water, get it at the right distance, the world is upside down. It doesn't actually make it so. You have to find conditions where you can eliminate all the variances like this to as much as possible. And you see that when people do, we see curvature, like Tommy's beautiful examples, like Rumpus's wind turbines as well.
Tommy's had nuclear mirage.
It just, and then you see people preaching, like Red Pill. So preaching is always a sign for me that
You
someone
just said
is trying
inferior
to.
mirages invalidate footage. His had an inferior mirage. I mean, come on, you're so stupid.
So preaching, interrupting, and obvious tactics, as well as insults, are an absolutely brilliant sign. Oh, and little whines, childish little remarks and snacks. Yeah, these are all signs of a person's character. And the fact that they can't answer questions, very basic ones, is a sign of their intellect. So I leave it to you who I'm talking about. Cheers, Jose.
Thank you very much, Dean. I appreciate it. Red Pill Philosophy.
Yeah, wow, what an incredible display of globe-tard dishonesty, mental illness, or just general retardation. Incredible. So I come in here, and then me and Chris Berry ask Bob, hey, are you considering the reality of compression and other variables, which Mick West said compression is real? And then we start tearing it apart to pieces, and we realize that the devil is always in the details. But when you just assume that everything is Earth curve, like these stupid fucking cult members have done for 2,500 years, everything looks like Earth curve when you want it to be. Then we moved on to Tommy, my good friend Tommy, who literally goes, the windmills in the horizon prove the Earth is a sphere, but there's a giant rock in the foreground hiding like 80% of the horizon. So it's like, Tommy, you couldn't have moved over a mile to get the giant obstruction, a rock, out of the way. I mean, it's almost like you had to have deliberately chosen that spot to obscure things. That, or again, you must be fucking retarded. Now, Dean's talking about, oh, you can't trust any footage. You know, you can't. You know, if it's wavy, it's invalid. Well, Aristotle, I mean, I'm sure he had the best conditions when you guys put his observations in the textbooks and used it as slam dunk proof for hundreds or thousands of years. But then Tommy's footage has an inferior mirage. So look, the globe is dead. Atheism is literally like, I mean, nothing has scared atheists more than flat Earth. That's why the top tier globe defenders are almost all atheists, dude. They're shitting their pants. And that's what we just witnessed here today. Thank you, Jose, for the great show. I really appreciate it.
Thank you very much. Even though you called in your last video the globe called whatever religion,
Yeah,
whatever.
the globe-tard safe space show, because that's what it is. Because everybody here is just afraid to debate Nathan Oakley, and that's just the truth.
It's cool. I enjoy the trolling, man. Thank you. All right. The Rumpus.
Right. Well, we had Chris claiming that refraction can account for things like the wind turbines. They can't, of course. They can only account for some
Never
changes.
said that.
Shut up. Chris did. So the claims that you can account for the images like the wind turbines and the things that Bob was presenting with refraction, you can't. You cannot do it. There's no way that you can account for the amount that's missing. And even if you talk about compression, they claim that you suddenly can fit 5 buildings, 5 floors or something, and a few pixels. And of course, if you take something that's even bigger, say you can have a building missing 20 floors, and they'll just say you can fit that in a few pixels. Similarly with the mountain, you cannot account for the massive amount that's missing. So, and on a flat Earth, of course, you should almost always be able to see the base of an object. All objects that are at sea level, if there's no obstruction, you should be able to see that, no matter how far it is away. So that is not something that we witness. And as for Chris's assertion that the fold line equates to the geometric horizon, is absolutely no basis for that, except for the fact that it seems convenient to just draw a geometric horizon where the fold line is. There's no scientific basis for that whatsoever. It's just what he wants to believe in, because it's just convenient and he's not interested in finding out the reason why. And unfortunately, with Red Pill, we've seen here that as well as being intellectually inadequate, he's socially inadequate. He seems incapable of containing himself, and he seems to be deliberately trying to disrupt the conversation in here because he doesn't like the way it goes. It invalidates his position. So the only options he's got are to disrupt the debate. Typical flat earther. There we go. Bye.
Thank you very much, Rumpus. Welcome anytime. Tommy.
Yeah, this was my first debate, and it was quite a shit show. I would more like to have a one-on-one with the Red Pill, who just left, by the way. I bitch made him 2 days ago, and I bitch made him today. That's why he ran away from our first debate. Anyone just can go back 2 days and see José's number 79 it is, and see that he just ran away from his challenge of me debating him. And yeah, I can see how he acts when he got something that disproves his beliefs. He goes total bananas, and that's rock in the foreground. It doesn't make any difference whatsoever. That's a rock. That's an island. Yeah. So again, José, thank you so much for having me. That was quite fun.
Thank you very much. Very, very nice show today. And Zinder.
I wanted to say that air flights kind of disprove the globe or the size of the globe, because here I'm gonna show you. Come on, can you please mute while I talk? Come on, guys.
I'm sorry.
What the fuck? Show some respect, please. Right.
How long are you going to do this game, Zinder?
Yeah.
Sorry to interrupt.
Come on, Rumpus. I'm talking. What the?
How much more of this game are you going to play?
Let him play the game. I mean, he got the last word. Please, Tommy, you got to mute because you.
Yeah, all are interrupting me because they are scared of what I'm going to show.
Tommy, mute.
Come on, dudes. Please. All right. So I'm going to show you a flight from here, from Melbourne to Santiago, which are here 11,000 kilometers. If you divide 11,000 kilometers by 900 kilometers per hour, you get 12 hours. And then you go to a website. You go to a website and you type in Santiago de Chile to Melbourne non-stop flight, which would be the most, 12 hour is enough for an airplane to fly, right? It has enough fuel for it, but nope, non-stop flight, nothing. Why don't they take this path, which is the shortest, to Santiago if the Earth was the sphere of the size they told us? Thank you very much.
Thank you very much. Before I start recording, thank you very much, everybody. I appreciate it. Dubbing good. Good guy.
Bob.
We had plans. Please don't interrupt. We had plans to meet in the near future, and I don't think that's going to happen because you have threatened me to report this show. You are a coward piece of shit. You are hitting on this show. I'm looking for the hangouts to block you because you are not welcome here anymore, Dubbing good. So you are done to me in this show. If you don't like it, then unsubscribe and don't watch it. That's all you can do. In Spanish, really quick. Para las personas que hablan español escuchando este show, algunos están interesados en hacer un episodio en español, por favor, contáctame en Skype. Mi nombre en Skype está en la caja de descripción. Me pueden encontrar en Discord o deja un mensaje bajo este episodio cuando el show suba a YouTube. Yo voy a monitorearlo. Cuando reciba los mensajes, trato de contactarte porque podemos hacer un episodio por lo menos de 1 hora en los próximos días en español. Y por lo menos si tengo 1 o 2 personas más para hablar del tema, entonces lo podemos hacer. Gracias, muchas gracias. Thank you very much, everybody in chat. I'll be back tomorrow with another episode of Open Discussion, Flat Earth, and more. And I'm going to stop the stream and start recording the after show. Boom!